वहाँ से रेडी है क्या सर? नहीं, स्टार्ट कर दो. If you want to keep there, that's fine. Okay. Venkat, could you please close the door? Okay. Good afternoon, everybody. Welcome to the 8th day of GIAN course on next-gen supply chains, harnessing IoT, digital twins, and AI-driven simulation. I hope you have been enjoying this session, this course. In today's session, we are going to talk about one of the important components of this GIAN course. What is it? The IoT, Internet of Things in Supply Chain and Logistics. So far we covered the digital twins, supply chain risk management, hands-on practice using any logistics. We also discussed the what is optimization, simulation, and then in the first session we talked about the differences between digitalization, and what is digital transformation. So in today's session we are going to talk about what is the use of or what is the role of this Internet of Things in supply chain and logistics. So I hope you will enjoy this session. So have you heard this term, guys? IoT? Yeah? Okay. Does anybody know what is it? What is the role of this? What does it do?
Connecting all the devices to internet.
Connecting.
Operating them.
Okay. Yeah, that's correct. Internet of Things means whatever the physical devices are there, we try to connect, over the internet, and sorry, and then we, make some data-driven decisions, or we try to optimize your processes using this Internet of Things devices. So these are the objectives of our today's session. At the end of session, you will be able to understand the role of IoT in modern supply chains. We will see a little bit background history of how in last 15 or 16 years, how the people were trying to track the products, goods movements from one point to another point. That we are going to see. Then we are going to talk about the key components of IoT architecture. What are the sensors normally used in supply chain and logistics management, and networks in supply chain management, and types of IoT sensors used in logistics. Basically, there are some types of this IoT Internet of Things as well. So we are going to see those types here as well. So before we start our today's session, I will show you a couple of pictures on the screen, and you want to tell me what is the name of that IoT devices. So like some of you said that you know the IoT devices, you know the purpose of IoT devices. So I will show you a couple of pictures here, and let me know what is the name of that IoT devices. What is it? Alexa. What does it do? Use our voice commands, and then
We'll process those commands.
if I keep that Alexa here, can I use it here? If I got that Alexa here, if I give some command, does it work here? Sorry?
It has to link with the smart devices.
Smart devices. What smart devices do we need here? What do you think? AC. Okay. What else? Fans. Projector. Okay. What else?
Fans, lights also.
Fans, lights. Yeah. Everything. Whatever the physical devices are there, If they are smart devices, you could say smart TV, smart your AC, smart bulb, smart fan. You can connect with the your Alexa, and then you can give Alexa, could you please turn on the lights? Could you please turn off the lights? Okay. So do you know exactly how does that work? It works when we give the command. How does it operate? How does it take that command and how does it process it?
First it will do speech recognition.
Okay. Then
Will understand the context and process.
okay. So does it send signal somewhere or does it locally manage the thing? What do you think?
It will have the range, right?
Sorry?
Range.
Within the range. Okay. But do you think that is there any other important storage or any other things we need for that device? Yeah, Wi-Fi connection, all those things you are saying. But what do you think? Do we use the cloud computing in that one? Be careful what you are saying. Do you use the cloud computing in that, not cloud computing, cloud, for example, in the IoT that Alexa, Amazon's Alexa, do you use it?
Yes, sir.
Okay. I think, yes, sir. Okay. What do you think? Do you use the Alexa? Sorry, no, I'm saying in that Alexa, do you use the cloud? Is there any purpose of cloud in that Alexa?
Yes, it uses because if it has to personalize according to the user, so it uses.
Okay, we'll see whether does it use the cloud or not. Okay, that's the one. What is this one? Easy, smart ones. Is it a IoT device? Yes. Why is it IoT device?
Sensor to track the steps, heartbeat.
Stakes. Okay, and then what does it show you? Overall, your performance, health performance. What is your heart rate? Whatever the calorie burns on all those things. Okay, that's the one. And then, is there any role of cloud in this one? What do you think? Let's see. We'll talk about that. What is this one? Barcode, RFID. What does it show? For what purpose do you use it?
Encoded version for the given.
Yeah, encoded. So what is the basically the to identify that object, to track that object, we use this RFID or QR codes. Okay. Then what is it? GPS tracking. What is the purpose of it? To track the location of your fleets, assets. That's your GPS devices. What is this one? Any idea? It is a pallet. Yeah, that's correct. It is a pallet. Yeah. What do you think? It is a pallet, but there is something in that pallet. Yeah, that's correct. Smart pallet. Why it is? Yeah. IoT. That's why it is called as smart pallet. Smart cart, smart watch. Why do we name it as a smart? Because it is connected to the internet. That's why it is connected IoT devices. It is connected over the internet. That's why it's a smart pallet. Sometimes when you see the factory 4.0 or a smart factory, when you call it as, or smart distribution center, in those smart distribution centers, if you look at the shelves where you keep the products, they are smart shelves. Why do you call them smart shelves? Because they exactly tell you what is the inventory available on that each shelf, and it will automatically replenish the inventory, place the order to the suppliers when the stock reaches to their reorder point. Okay, so that's your smart pallet, smart shelves, all those things. What is this? Easy. Drone. Okay. Again, what is the purpose of this one? There are many applications of the drone, like last mile delivery, or if you're in the warehouse as well, you can use it for the many applications. So that's your little bit idea about IoT devices. Okay. Now, any idea when this RFID or QR code has started? Who initially started using this one? What is the purpose of that one? Any idea? Any guess? So first in 1980s, industry started using the RFID, radio frequency identification tags, to find out to identify the objects, different kinds of objects. Then after that, in 1997, Kevin Ashton, he founded the MIT's Auto ID Center. This was the one of the research center. It was established at that time, and then Kevin explored this RFID, using RFID to track the products in Procter and Gamble supply chain. So he is the first guy who started using this RFID initially to track the the products movement in the supply chain. Then in 1990, he co-founded this MIT's Auto ID Center, and then coined this term, Internet of Things. So this lab was their research lab around 4 years, from 1999 until 2003, and in 2003 they closed it. And then because the purpose of this lab was to the collaboration between the academia and the private companies. Then after that, RFID tags are utilized to identify the objects and transmit information wirelessly. Okay? So you don't need the wired connection to transfer the information from one end to another end. That's the the wireless networks. So then introduction of wireless sensor networks. Sensor networks is a network of wireless devices that collect the information from the different sources, and that network then transmit the information to the other members of your supply chain. It enables sensing, tracking, and monitoring of objects. There are many applications of this RFID and these Internet of Things devices in healthcare, traffic management. In traffic management, it captures what is the flow of the vehicles, where the traffic is building, what is the congestion, and all those things. In healthcare as well, nowadays small devices are there, which when you use on your body, it will tell you exactly the pacemakers. Yeah, those thanks Rohit for suggestion. So those kind of small devices nowadays are coming to to identify any symptoms of or any problems related to your health. Integration of GPS devices, smartphones, social networks, cloud computing, and data analytics. So these are all basically RFID, and then they integrated with these GPS devices, smartphones, social networks, cloud computing, data analytics, because these IoT devices, they collect the huge amount of information, data from the different stages of your supply chain. And that's why then you need to process that data, you need to analyze that data and make some data driven decisions, some informed decisions. So that's why you need those cloud computing to store the data. Suppose your data is in small amount, do you need that cloud? What do you think? Do you need the cloud? So it depends on how much data you are collecting. There are different kinds of this cloud computing. There is a different purpose of that cloud computing. There are some other technologies that are available in Internet of Things area, based on the what is your purpose, based on the how much information or data is available. And data analytics, what is the purpose of data analytics? To analyze the personalized suggestions based on that data. These advancements support the contemporary concepts of IoT, Internet of Things devices. So what are the definitions? Any idea? Any standard definition? Does anybody know any definition? So the internet, there are various definitions available in the academic literature. So these are some of the well-known definitions I have mentioned on this slide. The Internet of Things extend the internets into the physical world. Why we are saying physical world? Because we try to connect the physical worlds to the internet. That's why we are saying IoT extends the internet into the physical worlds through widespread smart devices. Your smart, the AC, smart fans, smart tab, whatever those smart devices we are talking about, we try to connect those devices with the internet over this, with the internet, with sensing, identification and communication capabilities, enabling new applications and services. So when you sense, when you collect the data, when you transmit that data, then you analyze that one and you make some decisions based on that processed data. So it provide there are many applications, as I said, of these IoT devices in healthcare, traffic, and in many other areas. Another very interesting definition given by the Gubi et al. In 2013. So what they mentioned basically, it refers to the connection of smart devices. Just now we talked about. If we have the Alexa here, that Alexa will not work here. Why? Because we don't have any smart devices here. Okay, so that's why. So it is a connection of smart devices that sense. What it sense? Your commands. When you say, Alexa, could you please turn on the light? It will sense what you are saying. Then collect that information. It takes your request, whatever the command you are trying to give to that Alexa, share data across platforms. Then, as I said, sometimes based on the type of data, amount of data, some platforms or some IoT devices, they manage the information locally. They don't need to share that information to the cloud. They manage that information locally and they take their decisions based on the whatever the information available. But sometimes when data is used, they cannot manage that information locally or decentralized in a manner. Then they need to send that information to their whatever the cloud is there, and then they process that information there, and then it will execute your command. So share data across platforms through a unified system. It enables real-time insights and innovative applications using large-scale sensing, data analytics, and cloud computing. Okay, so they mainly focused on this large-scale, huge amount of big data because as we know, supply chain consists of different members, starting from the supplier to the your customers, and there are many third-party, fourth-party logistics providers are there. So huge amount of data is generated. So you cannot manage that data locally. You need some cloud computing, cloud systems where you can process this, analyze this huge amount of data, and find out some insights from that data. Another one given by this Zhu and other co-authors, IoT is a global network of physical and virtual objects with unique identities and smart interfaces, enabling seamless communication. Seamless communication between these physical, your smart devices and the cloud, and then integration through a standard protocols. So there are some protocols as well when you that platform, that system transfers the information or whatever the command it takes. So they follow some kind of protocols as well. So these are some of the definitions of IoT. But if you look at the specific or this is the general definition. There is no role of any basically the supply chain or all those things. So if you go in depth and when you try to find out the definition of IoT from supply chain perspective, so here is the definition of Internet of Things in supply chain. Similar kind of things, but just from supply chain point of view. The Internet of Things is a network of physical objects that are digitally connected. Physical objects, but that are, I have shown you that palette. Okay, so that you can have. Yeah, you can have the normal palette and you can have the smart, palette. Okay, smart in the normal palette we don't have any IoT devices there that is connected to the internet. But in smart palette we have got the IoT devices to track the movements of that palette, how much load is there, all those things it will track, and then it will share that information to the cloud and other members involved in that supply chain. So in network of physical objects could be your fleets, assets, or in the manufacturing factory, like machines are there, forklift trucks, so many things are there. Then your trucks, vehicles, as I said, or in distribution centers, some the shelves are there, or some other physical objects are there that are digitally connected to sense, monitor. So sense means it collects the information. It collects the information from the surrounding, and then it monitors the performance as well. Why we are saying monitoring? Suppose you have got the normal traditional machine in your factory. When you use some or when you attach some IoT devices there, it will monitor the performance of that machine. It will tell you that at what speed that machine is running, what is the production of that machine, and when that machine may fail in the future. If you run that machine at that speed, it will do that analysis, and it will tell you the how much life left in that machine, so that you can do some predictive maintenance. So before the occurrence of any unexpected machine failure or machine breakdown, with the help of those devices, you can do those preventive maintenance. Interact within a company. So these devices, they can interact with each other within your company, sometimes between the company and its supply chain, enabling agility, visibility, tracking, and information sharing. What is this agility, visibility? I think day before yesterday we talked about these strategies in supply chain risk management. What is agility and what is visibility? Flexibility to adapt. Okay. What is visibility? End-to-end transparency from supplier end to the customer end. That's your visibility. Agility, there is a difference between agility and flexibility. What is the difference? I talked about 5 important supply chain resilience strategy. First one was visibility. Second one was flexibility. Third one was agility. Fourth one was collaboration. What was the fifth one? Redundancy. And I clearly mentioned that the difference between agility and the flexibility. If suppose your demand changes, demand goes up or down, or something happened, how fast, when you can make the changes in your supply chain, that is your flexible network. If you can make the changes in your supply chain network, suppose one of the suppliers stops supplying you the products, you have got only limited suppliers, but still you are managing and running your business, making the products. So that's your flexibility. Or you have some backup suppliers or something else. With the help of those resources, you are managing that unexpected event. It means your network is flexible. What is agility? You are making the changes in your supply chain because of the unexpected event, but that change is very fast. That is called agility. If that change is not fast, it means that your supply chain is not agile. Got it? So flexibility means you are making the changes in your supply chain because of the whatever the unexpected events are there. So that means you can say that suppose you are supplying the products to the 2 markets, and demand from one market significantly decreased. Now what you can do? You reduce your production level. Why? Because there is no demand from one market. It means how fast you can reduce your production level. So that is your agility. Suppose you are reducing it, but if it is not that much fast, means your supply chain is flexible, but your supply chain is not agile. So that's your the agility, visibility, tracking, and information sharing to facilitate timely planning and control and coordination of the supply chain process. So when again, visibility means again sharing of timely and accurate information with the other members. What happened in the Nokia Ericsson case? That information was not passed very fast from the supplier Philips end to the Nokia and Ericsson end, but Nokia had taken the proactive approach. They went and they saw what happened exactly, and that's why they had taken some couple of options. But Ericsson's case, they didn't get any information, timely information from the Philips, and that's why they incurred that 400 million of loss. So that's why whenever you look at any supply chain, so when you say the transparency, visibility, it means that whatever the information, what is the stock level, what is the demand level, all that information which is not confidential. Again, I am saying that sharing the information, you might say that okay, Danny is saying okay, sharing information, it doesn't mean that share all the information, whatever confidential information with your supply chain members. Suppose I am a supplier, I am supplying the products, raw material components, so 4 or 5 manufacturers. 4 or 5 manufacturers. So those 4 or 5 manufacturers, they might be competitors. Okay, so you cannot share the information from your one of the clients with the other members. Okay, so don't any member, they don't share the basically the confidential information, but whatever the information is available to enhance or to optimize your supply chain network, that kind of information we can very easily share with the other members. Suppose I am experiencing some problem as a supplier, so it's my job to inform my manufacturer so that they can take some proactive actions to manage their supply chain. So that is not a confidential information. That is a we can say the information which will run your supply chain smoothly. You may not face any problems. So those kind of information or data you can share. So Internet of Things, from the supply chain perspective, there are 4 key features of this definition. The requirement for digital connectivity of the physical things in the supply chain. So in the physical supply chain, so you have got the suppliers, you have got the factories, distributors, retailers, and all the members, whoever like tier 2 supplier, tier 3 suppliers who are available or who are involved in that supplier, they should be connected to you through this cloud, through this digital network. Because suppose you have got 1,000 suppliers, for example in automotive supply chain, out of those 1,000 suppliers, 900 suppliers are digitally connected and 100 suppliers are not connected. Do you think that is it making sense? It doesn't make sense. Why? Because you are not getting the exact information from that remaining 100 suppliers. So that each and every member, they should send the timely information with the everybody or the the other members of supply chain. I think I gave you one example of Boeing 787. If I have the paper as well, I will share you. Boeing 787 Dreamliner. So when they converted their traditional supply chain into the unconventional supply chain, what was the traditional supply chain? In traditional supply chain, they had thousands of suppliers supplying the each part and component to the Boeing. And what was the Boeing job? Boeing jobs was to collect those parts, component, and do this assembly of that aircraft. Do you know how much time do you need to make the one assembly of the aircraft? Any idea? 30 days, 1 month. And in order to make one aircraft, you need almost 6 billion to 10 billion of money. Okay. So what happened? Again, very famous and classic case study. In 1990s, do you know Boeing from which area? The Boeing company? US. And there is another competitor. What is that? Airbus. Where is it from? Yeah. Airbus is from Europe. Okay. So again, very two competitor. Like similarly, if you look at the Nokia and Ericsson case, similarly, like these are the Boeing and Airbus. They are the major currently the top players in the aircraft manufacturing industry. So very interesting. If you see the overall picture of the revenue, what kind of products they are making. So in 1990s, basically what happened? Boeing lost some of its customers to the Airbus, and because of some new aircrafts manufactured by the Airbus. So Boeing had two options: either to increase their sales or relaunch some new products. So what Boeing decided? Boeing decided to make this revolutionary, the aircraft. It's called Boeing 787. Before that, our the largest aircraft is the Airbus, I think 34 something, I don't know the exact number, but that is the largest aircraft currently in the world. So Boeing wanted to make something revolutionary. Why? Because earlier, in order to make that aircraft, aluminum was used to make that aircraft. But Boeing wanted to make the aircraft lightweight. So they wanted to use the composite material more than 50%. Okay, and before that nobody was used that composite material for 50%. And then what they did, because of that composite material, there are some benefits. So the pressure in your cabin, it is good pressure. The comfort will be increased. And then because of the lightweight, what will happen? If the weight of the aircraft is lightweight, carrying capacity will increase and you can cover the longer distances. So the immediate customers, who are the immediate customers of Boeing? Do you know? Who are the customers of Boeing? Who are the customers of Boeing or Airbus? Immediate customers, but who are them? Military. Okay, yeah, military is the one. Other? Airlines. Airlines, they are the immediate customers. And who are the customers of airlines? We are the customers of airlines. So what happened at that time? So Boeing, wanted to use this composite material, which had couple of benefits, but nobody tested before that one. And another major thing they did, they changed their supply chain. They went into the unconventional network. What was that unconventional network? Their focus was on two things. One was to reduce the development time and to reduce the development cost. So in order to reduce that development time and development cost, what they did, they said that in normal supply chain, conventional supply chain, we take the parts and components from 1,000 suppliers and we make the assembly. Now what we do, we don't go with the 1,000 suppliers. What we do, we keep only the 50 strategic suppliers, important suppliers, and we ask them, you don't send us the parts and components. Then what you do, you take the parts and components from tier 2 suppliers, you make the subsection of that aircraft and you give us the subsection. And then we do the assembly of that aircraft with the help of those subsection, and their goal was to make that assembly within 3 days. Look at, in initial case, it was 30 days, and in this unconventional supply chain, they wanted to make it in 3 days. And another, positive thing they wanted to make into that aircraft is to the modular engine, modular design of that aircraft. So that airlines can use two kinds of engine. One is the Rolls-Royce engine and another one is the GE's engine. And their initial plan was to the changeover time. Changeover time, they thought that initially it would take 24 hours to change the from one engine to another engine. But what happened when they took this, the very big project? If you look at that team which was managing that whole project, there was nobody expert from the supply chain risk management perspective. And because they were doing so many changes in that, they were using the composite material, they did the changes in their supply chain, and they thought that everything will go smoothly. So in 2003, they announced these projects. After that, in 1 or 2 years, or not 1 or 3 or 4 years, they received the orders of near about 900 aircrafts from the different airlines. Okay, so everything was so high. If you look at their share prices as well in 2003, I have got the slides as well. In 2003, their share price was 30 USD. In 3-4 years, share price went to the more than 100 USD. Okay, and then everything was working fine. But when the actual production started, actual supply chain, because these suppliers, tier 1 suppliers, they never made the subsections before that. They had no idea how to make those subsections. That was the thing. And another very interesting contract, they basically used Boeing in their in that case study. Have you heard this risk sharing contract? There are different contracts in the supply chain. Risk sharing contract, fixed penalty contract, and so on. Revenue buyback. Buyback means when if you are taking some products from the the distributor, when you don't sell that, the distributor will take back those components. Revenue sharing contract. That's why. Yeah, quantity flexibility. Yeah, that's true. So they used the risk sharing contract, Boeing. And what was that contract? That contract was that one of the important clause in that contract was, it was mentioned, they had 50 strategic suppliers. The contract says that if one of the suppliers of that 50 strategic supplier delays the products, delays the subsection, sorry, not that one. So if Boeing failed to deliver the the first its aircraft to the customers, to its Boeing's customers means airlines, then nobody will get the payment out of those 50 strategic suppliers. It was unfair, because suppose out of that 50 suppliers, if one supplier couldn't supply the products on time, remaining 49 suppliers unfairly getting penalized. So that was the problem in their risk sharing contract. Another problem, what happened, because of this unconventional supply chain, what they did, they thought that we need to get the timely and accurate information from the all suppliers. So they hired one system, digital system, where that all these tier 2, tier 3 members, they will update the information there. Nobody had the experience of doing this, update of data and sharing everything before that one. So tier 2 suppliers, they are one of the tier 2 suppliers, they hired another third party to update the information. And Boeing was not aware of that, the third party, whatever the digital tool they use. So that Boeing didn't get the information about from their suppliers what was going. So at the end of the day, at the end of like 5-6 years, Boeing couldn't deliver those, aircrafts on time, and then they announced the, the delays, and then airlines started canceling the order. Airline said that, this is not a cup of tea of Boeing. They cannot do this with the help of this composite material and all those things. And they went to Boeing and said that, okay, we don't want to buy this 787. Now we want to lease it on a rental basis. We can go it, or you could provide us some additional, aircrafts. So that is again very famous and interesting case study. It shows that, if one of the members or some members in your supply chain, if they are not updating the information or they are not sharing the timely information, your supply chain will be affected because of that one. The nature of this connectivity is proactive, allowing for data storage, analysis, and sharing. Again, because when you share the data, you can store into the cloud, and other members, they can access that data, they can do the analysis and sharing. The communication involves processes within an organization as well as inter-organizational transaction covering major supply chains. So when we say the data should be shared with the other members, it's not like that only manufacturer and distributor. All the processes involved in that supply chain, and then communication should be, the seamless communication, so that we don't face any unexpected events.
Pardon, likewise in supermarket, the point of sales data is there to be in every supply chain partner.
Yes.
Not only do like D-Mart, the Money Mart in India.
Yeah, that's true, Rohit. Yeah. Then last one is IoT will facilitate planning, control, and coordination of the supply chain process. Okay. Again, data is, we are saying huge amount of data is generated. You cannot transfer that data with your normal Excel file or anything. Okay. And again, how much time do you need to share that data, and how you can share that data? What happens if that data is leaked in between? So that's why this IoT will sense, will collect that data, process that data, analyze it, and then it will help you to make some data-driven decisions, or informed decisions. So now basically how it works, I think Venkat, you said that it takes your command, and you said that I think it uses the cloud. So I asked whether does this Alexa use the cloud computing or not. So let's see basically how any generic IoT device works. Any idea? Any important steps? First is the data collection. Yeah, you give the command. What is next? Processing the data. What? Analyzing the data and finding out some insights. Okay. Yeah, those are the important steps. How it works basically. First one is the data collection stage. Okay. So if you look at the factory as well, when you attach your IoT devices, so it will it will check what is the vibration, what is the speed, how much products you are making on that machine. If you attach the the IoT devices on forklift trucks, or within your the inside your vehicles. So if you want to monitor the temperature, it will tell you how much temperature inside that your fleet vehicle, and when do you need to make the changes, those kind of things. So data collection is the first stage. You need to sense the data with the help of these IoT devices, sensor, RFID, and then you see what kind of data is there. Okay, so sensors and actuators, we use the RFID, QR codes, cameras and image sensors. Does anybody tell me the use of these cameras or image sensors? Any example? Where do you use the cameras? Which kind of data do you analyze this one? Detect. Yeah, that is the one thing. And in again traffic management, with the help of the camera, you capture how many vehicles are there on the road, and then accordingly it will provide that data. It will share with the your cloud. cameras, again image sensors and wearable devices. Wearable devices, we are talking about smartwatch, but if you look at, if you go to the smart factory, the workers, the employees, those who are working, they also use the cameras on their head and then the other smart devices, so that you can analyze their movements and you can find out what is their productivity rate, productivity, and so what is their basically the, you know, the some other performance or KPIs, you can do that. So this is your data collections. So try to collect the data in different forms from your physical devices, whatever those devices are there. It could be your vehicles, it could be your warehouse, factory, even suppliers, location, machineries, anything. Then once data is collected, then what is next? Process the data. Do you directly start processing? Suppose data is huge amount of data. Do you start processing? Analyze. Yeah. Process the data means analyzing the data. Okay. What do? You collected the huge amount of data, then you start processing that data. Where do you process? Where do you analyze it? Think. You collected the data. What is the next step? You are saying processing or analyzing the data. Where do you do that? Do you do the process on your laptop? Okay, it will cloud platform. That's one. So if data is your big data, huge amount of data is there, you cannot open that data in your laptop, in your PC, and you cannot analyze, or you cannot basically see that data as well if it is a huge amount of data. Okay. So in that case, what you need to do? You need to transmit that data to a platform where you can process, analyze that data. So second stage is data transmission. Once you collect that data, you transfer that data to your cloud, and there are different cloud providers are there, and then you keep your data there, and you, the next stage you do the analysis, whatever you want to do, that is the one. Any example of any cloud providers? Azure, yeah. So those are the AWS, other Drive, Google Drive. That is the one of the, you know, basic simple example. Those are the, you know, the examples of your cloud providers. Short range communication, again. So when you say the data transmission, so whether you want to transfer that data to your cloud, centrally manage the provider location, or you want to share that data with your local, you know, the platform where you manage that information locally. For short range communication, you can use the Bluetooth or Wi-Fi to transfer that information, whatever the data is available. Long range communication, you go with the cellular, this LP WAN, wired Ethernet, or fiber optics. Okay, because huge amount of data is there, and you need to transfer over the, you know, centrally for the long distances. So that's the example of your data transmission technologies. Then next is the your data analysis or data processing. What do you do? What do you do in the data processing or analysis? Analyze the data, find out the hidden patterns, insights. If you want to predict the demand, predict the demand. If you want to optimize something, in case of machine, if you want to find out the life left in that machine, you do it. Suppose if you want to find out the traffic on any single road, you can do that. What else you could do? If you want to optimize something, you could optimize there. Okay. There are various ways to analyze that data. So what are those ways? Cloud computing is one of the ways. Then edge computing is there, fog computing is there, big data analytics, AI, digital twins. How many of you heard these terms? Edge computing, fog computing? No. Yeah, go on.
Instead of processing data on the cloud, the data will be processed on the local machine. So this is called as edge computing.
Oh.
And the pros of this is like the computation will be more faster and the latency will be very less.
Okay.
In case of edge computing.
Okay. Any example? Good. You rightly give me the answer.
We can take the example of self-driving car.
Hmm.
The response time is very fast.
Mhm.
So if the car is processing data from the cloud, it will
Okay, good one. Have you understood what he said, guys? So we'll talk about all these, and we are going to see the differences of this edge computing as well. That's why I was saying that. Then what do you think? Does Alexa use the which of this technology? Edge, fog, or cloud computing? What do you think? It uses the basically cloud computing, sends the information command taken by you, given by you, and then it will AWS will execute that the command, analyze it, and then will tell you which actions need to be taken. Then big data analytics, AI, and digital twins. Then execution. Last one is the execution. Execute whatever the things you want to do, like actuators, smart home and industrial controllers, automated machines, AI and machine learning models, smart assistants and interfaces. If you look at this Alexa, so what is, you say, Alexa, could you please turn on the light? Why do you say Alexa? Can't you say could you please turn on the light? What is this Alexa means? Any idea? Activation. That is a wake up word. Okay, in order to activate that device, you want to say Alexa, turn on the light. Okay, so that the command when you give. So Alexa, when you say Alexa, it is activated, that device, and then when you say turn on the light, it will take that command. Okay, the command is turn on the lights. Okay, then what is next? Take data transmission. Then the Alexa, that device, IoT device, will transfer that information to the AWS cloud. Okay, once that information goes there, then AWS cloud will analyze your command. Okay, do the analysis, cloud computing, and then it will tell the Alexa, or it will execute the basically that command given by you, turning on the light. Then Alexa will say that turning the lights on, and then basically at that time it will connect that the cloud server. It will connect to that smart device, whatever smart bulb you are saying. It will connect to that one, and then your lights will be turned on at that time. So this is the whole process of any IoT devices working. Whatever the command you give, that is the way they collect the information, they collect the data. Once that data is collected, based on which platform it is using, how much data is available, whether it is a small amount of data, huge amount of data, it will decide whether they want to share that data to the cloud or they want to manage it locally. So there are some benefits as well. As he mentioned, latency. When you transfer the data to the cloud, what happens? Distance, basically. There are chances of delay in sharing that information with your cloud. If the connectivity is not good, your data will not be shared with the cloud on time. There might be some delay. Similarly, when the data is analyzed there, and when the cloud starts executing your order, there might be delay again, some kind of delay. So for those kind of things, if you want to take some immediate action, okay, then you cannot, there is no need to share that data from your devices, whatever devices you are connected to the cloud. Why? Because you may face some delay when transferring that data, when getting the actions recommended by your whatever the platform provider is there. And that's why if you look at the driverless car, I will show you the video as well. So in the driverless car, they don't use the cloud computing. Why? Because of this high latency in cloud computing. They go with the edge computing. Why? Because they manage that information locally. Suppose there is because I will show you that picture as well of that driverless car. So there are IoT devices, cameras, sensors attached to everywhere on that car. If suppose that sensor detected that there is some object in front of that car, and if you are using cloud computing, okay, it is taking that information, object is front of you, then you are transferring that information to the cloud is analyzing that data, then it is asking you to stop. Meanwhile, you cross that object. What is the use of your cloud computing? That's why when you see that object in front of you, then you should manage it locally, and you should immediately apply the brake. Okay, that car should apply the brake immediately. So that's the use of your edge computing. Fog computing is middle level in between. Okay, if you don't want to manage it locally, or if you don't want to send it to the your cloud, then that is called fog computing. So smart grid in smart cities, you can use the fog computing. So what are the technologies associated with the IoT? So we talked about cloud computing, fog computing, but what else? Data collection, what technologies do you need? Sensors, RFIDs, okay. What else? Hmm? Tell me. Sensors, RFIDs. Then once you collect the data, what is the next stage? Data transmission. What technologies do you need? Wireless. What is it? What are the technologies do you need? Communication technologies. Bluetooth, Wi-Fi, okay, your Ethernet or whatever the technologies you are using. Transmission done. What next? Storage or analysis. What technologies are there? Cloud, your edge, fog. Then what is the next? Execution. So you want to execute. So what are the technologies? Actuators. Okay. So when you say basically you want to turn on the lights, if there is an actuator, then only it will execute that command. If there are no actuators which are not connected to the internet, how it will be? It will turn on your lights, or it will execute your action or command. So actuators you need there. RFID, then RFID, CMS, barcode, smartphone you need, then wireless sensor network, cloud computing, then internet, 3G, 4G, Wi-Fi, transmission technologies you need, location-based service, again collecting the information, near-field communication, social networks. So these are some of the technologies needed for your IoT devices, for your IoT, Internet of Things technologies. Sensors. First thing is we need the sensors to collect the data. So you can see some examples of sensors here. Accelerometer, if you want to find out the speed, accelerate of your vehicle or any fleet. Then battery sensors, camera. So it is not one kind of data we collect from your supply chain. Different kinds of data is needed, and for these different kinds of data you need the different sensors. Temperature related. Suppose you are transferring the perishable products and you want to know more, you want to find out what is the temperature inside your vehicle. So you need the temperatures sensor, humidity sensor, pressure sensors, moisture sensors, so many, pyrometer, temperature, weight sensors. So these are some of the examples of the sensors that you could use for the IoT applications in supply chain management. So it again varies from your the supply chain type. If you are into the food supply chain, so you may need specific kinds of the products or the sensors. If you are into your automotive supply chain or fashion supply chain, so you need some different kinds of sensors. So types of IoTs, do you know? There are types of IoTs as well. So what are those types of IoTs? So broadly there are 3 different types of IoTs. What are those IoT types? Consumer Internet of Things. What does it mean? Its name suggests that. Consumer Internet of Things. Designed for personal use. Enhancing everyday convenience and personal well-being. That's consumer. Focus is on consumer. IoT devices used to improve the convenience, well-being of the people. That's why it is called Consumer Internet of Things. For example, your smartwatch. Why do you use the smartwatch? Monitoring. You want to monitor your health. You want to know more when my heartbeats gets increased, what is your sugar level, oxygen level, all those things. I don't want to face any unexpected problems. That's why we use the smartwatch. Then your smart home. What are the examples of some kind of IoT devices in smart home? Alexa is one. Your AC, smart AC, smart bulbs, maintaining room temperature. Yeah. Any other? Smart your TV, everything nowadays. If you look at, I will show you one picture as well. In fact, from now you can get the smart curtain as well. You don't need to go and ask you just say, Alexa, could you please open the curtains? Alexa will open the curtains. Okay, that much advanced technologies are there. Everything starting, you might know the Apple Ring camera as well. If somebody comes to your door, you can answer the door from here. Yes. So those are the basically things, you can say for the consumer related things. Okay, designed for personal use, enhancing the well-being, everyday convenience. And what is the data type here? Do you collect the huge amount of data like your supply chain? No, small volume of data. Suppose you are taking the example of smartwatch. What is your steps? How much steps you are taking? What is your heart rate, or what you are doing, what kind of activity you are doing. So on that basis, it collects that small volume of data, and then you don't need to send that small volume of data to the cloud. Why? You can locally manage that data on your whatever device is there. If huge amount of data is there, then only you need the cloud computing. For this small amount of data, you don't need to go to the cloud and ask, can you process this one, and then again that latency problem will be there. Okay, so you don't want to do that one. So that's your consumer internet of things. Next one is the commercial internet of things. Now personal use is done. Obviously, what is next? Expand it. Go to the IoT application in commercial settings like office buildings, hotels, retail shop, hospitals, aiming to improve the performance, operational efficiency, and customer experience. Connected devices in retail and healthcare applications. As I said, if you have got the one big warehouse, and in that big warehouse, smart pallet is one example. Then smart shelves, they see track the products available onto that shelf, and as soon as they reach to your reordering point, they will start replenishing the products. You don't need to do anything. Smart pallets, then your smart forklift trucks. It will capture basically when you move that forklift trucks. It will check everything surrounding that area, whether it is safe to drive or not. Okay? So the applications in commercial setting, it could be in your office building, hotels, retail shop, hospitals. The application of IoT devices in these commercial settings, we call it as a commercial internet of things. Then next one is the industrial internet of things. So basically in manufacturing, energy, or logistics, in those sectors, like the aim is to enhance the efficiency, safety, and productivity in industrial sectors like manufacturing, energy, logistics. Suppose you are doing the predictive maintenance systems, industrial automation, supply chain optimization. Predictive maintenance means, as I gave the example, if you have got the couple of machines in your factory and you attach the IoT devices there, it will tell you, it will analyze, monitor the production level, the whatever the speed that you are doing there, and it will tell you how much time is left into that machine's useful life, when that machine need the maintenance. So those kind of operations you could do there. So that is the industrial internet of things. The applications of this internet of things in these industrial sectors, then the purpose is to enhance the efficiency, safety, and productivity. Any idea? Any doubts? Any questions? Yeah.
I want to state one. I'm not a question or doubt.
Okay.
I'm giving that example. You are giving commercial internet of things. Same will be applicable to industrial warehouse also.
Yes.
I'm giving one example from Kanban.
Kanban. Yes. Yeah.
In Kanban card, they teach cameras. In open boxes, latest I think 100 items are kept there. The stock level reaches to 500. The up to 600, the green light will blink.
Blink. Yeah.
After that, 500, it will blink yellow light.
Yeah.
And 400 units, it will blink
Red light. Yeah. Interesting one. Yes. Yeah. So yeah.
Use all these industrial internet of things there also. Sensor cameras.
Yes. That's true. That's why, as I was saying, smart your shelves or smart pallets are there. They have so many applications of these industrial internet of things. Have you heard this term, Internet of Everything? Now, Internet of things are done. There are some types. What is Internet of Everything? Everything. What everything? What do you mean? Can you connect this chair to the internet then? Can I connect this bottle to internet? Adjusted. Yes, yes. So, Internet of Everything is the next level of Internet of Things, I would say. IoT is the Internet of Everything is the network connection of people, process, data, and things. So, basically, how the data is generated from people and things. Okay, so the workers, the people, those who are working, and the things like your physical devices. Data is generated from these two, basically sources, people and things. When you get the data from these two sources, then you need to process that. There should be some systematic process to analyze that data, to find out the insights. So that's your Internet of Things. So normally in our your consumer Internet of Things, commercial, industrial Internet of Things, we were talking about only the things. We haven't discussed the people. The people component is very important. We also generate huge amount of data. So here we need to consider the data generated from the people and the things, and then you process that data. There should be some process to manage that data, to find the insights that will help to increase the value of the product, and increase value that occurs as everything joins the network. Everything is connected to the internet. So these are the basically the four important components of the Internet of Everything. First one is the people, connecting people in more relevant, valuable ways. Okay, suppose you have Internet of Things devices are there, and the people, they are not using those devices. What is the use of that? Do you really think that you are gonna get some useful insights from that one? What do you think? No. So that's why the people who are playing important part in your supply chain, they should also aware of this the advanced technology, Internet of Things. That only then only your whole the supply chain, whole network will be optimized or will be improved. Okay. Then things, physical devices and objects connected to the internet and each other for intelligent decision making. Okay. So again, as I said, people and things, these are the two important sources of your data generation. Once you get that data, you then model that data, analyze that data, and find out some insights from that data. So IoT, it includes these four important components: people, things, data, leveraging data into more useful information for decision making. I think on 1st or 2nd day somebody was asking me, I think you were asking, so how can we contribute into this digital supply chain? Okay, so this is the way you can contribute. Suppose you know the benefits of those technology, so you should use those technologies. Why? So that you can streamline those processes, you can reduce the time, you can reduce the cost, you can make the things better. Okay, suppose because of all those things, you know the benefits, and if you are still using the traditional technology, what is the use of your those technologies? Okay, so that's the the role of people in this Internet of Things or in this digital supply chain process, delivering the right information to the right person or machine in the at the right time. Okay, so again, Internet of Things, the purpose is to transfer or share that information very fast from one point to another point. Okay, suppose if you want to transfer some information available, how much production level of one machine, so that sensor, that IoT device will automatically transfer that information to the other members, other network, other machines. So you don't need to go check and then go to the another machine and check. Those machines to machine conversation will happen there. Okay, you don't need to play any part there. So that's your process. The Internet of Everything can help governments create value by saving money. Any example how you could use Internet of Everything for any problem that you face on a daily basis? Any example? Help go create value by saving money, improving employee productivity, generating new revenue, and enhancing citizen benefits. Nowadays, smart parkings are coming up. Okay, so if there is a traditional, the spaces there in metro cities, parking is a big problem. Okay, you can, convert the traditional your parking spaces into the some smart parking zone. You just need to apply a couple of sensors, IoT devices on that machine, whatever the machine is there in that parking area. You need to apply a couple of cameras there basically to capture how many vehicles are there, whether that the parking space is free or not, and that is connected to then your internet, and then whoever is trying to find out the parking space, they can see, okay, exactly real time information, how many vehicles are available in that parking area, and yeah, and it is there any is it there any parking space or not. So those kind of things you could do to make the things better, to improve the operations.
A smart tracking system also can reduce the accidental occurrences.
Accident, yes.
They are talking about overall safety.
Yes, accidental occurrences you can avoid because of this smart tracking. People, as I said, will connect to the internet in more valuable ways beyond traditional devices, PCs, smartphones. Future possibilities, solvable pills that monitor health and send data to doctors. I don't know whether you are aware or not. I think when ChatGPT initially started, you can search on Google as well. There was news from US. Okay, one lady, she was trying to find out the disease of her son. She went to so many doctors, but nobody could find out the exact disease that, or exact the problem that her son was facing. Then at one day what she did, she used the chat gpt to feed to input all the reports and everything, and she asked chat gpt, could you please tell me what kind of problem my son is facing? And then chat gpt said that, I think based on whatever the reports, whatever the things you have uploaded, it looks like that he is suffering from this problem, so you could go with those kind of consultants. Then she went to that consultant, and literally that the boy, he was facing the same problem. So these kind of advanced applications you can see because of this internet of things. Soluble pills that monitor health and send data to doctors. As I said, small chips are coming, like as he said, peacemakers that will help you to track your health performance, and before the occurrence of any the big problem, any health issue, you could avoid those things.
Doctors also inject some implants,
Implants, and now, and another example, you could you might have seen that robots, they are doing the surgeries nowadays. Okay, because of these are again the advanced technologies. Wearable sensors in clothing to track the vital signs. Okay, so nowadays, do you know, I think this is just another application, I could say. I read somewhere that you buy suppose some clothes, t-shirt, pants or something like that, and there is a return policy, like you can return after 30 days, 15 days. Suppose if you use that whatever the the cloth, t-shirt you bought in that 30 days for maximum time, and you are trying to return it again, there are small chips now they are trying to use into their those clothes, so that it will tell you exactly how much it came into the external environment and whether you have really used during those 30 days or not. So those kind of advanced applications nowadays, they are coming because of these technologies. People as a node, individuals will become nodes in the internet, continuously emitting personal data for real-time monitoring. Data, IoT devices collect data and stream into a central location for analysis. Central locations means your cloud. Data evolves into intelligent insights that go beyond raw information, and the transformation allows for faster, smart decision based on real-time information. Imagine if you look at that Alexa, it takes your command, it sends to the cloud, AWS cloud, it analyzes that and it executes within a fraction of your minute or second. So you can see how fast that information is going from one node to another node, and then from that node to the cloud, and then again they are executing the action because of all these the communication technologies, 5G, 4G and all those things. Effective environmental control through actionable data. Next one is things. physical items like sensor, consumer devices, enterprise assets connected to the internet and each other. Key features of internet of everything: data sensing and context awareness, providing experiential information for smarter decisions. Smart sensors in structures like bridges, disposable sensors on everyday items like milk cartons. So you can see when you want to dispose those, the cartons and all those things. Process ensure entities like people, data, things, they work together to deliver a value. If there is no systematic process available, we will talk about the architecture as well, because we are saying that for Alexa, what are the important steps are there in that process? We are giving the command, Alexa is taking that command, it is then sending to the cloud, and then cloud is executing that one, analyzing it, and then executing. So there are some important steps available. So there are some architectures as well. So based on what kind of data is there, how you are processing data. Sometimes cloud is there, sometimes they do the local processing as well. So that's why process again plays an important role in this internet of everything, so that all these people, things, data, they work together to create some value services to the people. Correct process enable right information delivered to the right person, right time and right way. Okay, if suppose right information is not passed to the other members, we have seen that what could happen in Nokia Ericsson case. Then a right time, again if there is a delay, in best example is the driverless car. If there is a sudden delay in that executing, it will be a huge problem. So that's why right time and again in the right way. If you don't pass that information in a right way, how could other person can analyze or understand that information?
Pardon, I want to cite something. I can't recall the name of that particular automotive company. They are using some sensors abroad, and using that sensors, basically they can identify that person is basically driving in the right manner or not, he's taking wrong turn or not, and depending on that, the warranty of that particular car might be terminated, and the insurance might be also terminated. But if that person drives in a very good natural way, then they can extend the insurance also.
Yes. So
I have heard this example, but I don't recall the name.
so I don't know whether you are aware or not, but in Western countries, there, suppose in Japan, you can see online videos as well. When driver they drive, they drive the bus, public transportation. There are some cameras in front of there, and they are continuously monitoring the eyes, the whether, if suppose they are thinking that driver is sleeping, that bus will stop at that time.
Yes.
Okay, continuously. There are some cars as well. If they think that you are a drink and drive, so if you are drinking and driving, the car will not start. So these are the advanced technologies are already happening, in this world.
Like in credit card, they generate some civil score.
Yeah.
They also generate some safety score. Like
Safeties, yes, yeah, that's
I
true.
can't recall that.
Yeah. IoT architecture, as I said, the process is one of the important components in Internet of Everything, because all these physical devices, things, sensors, all those things, they should collaborate to create some kind of value. So there are three types of IoT architecture. So what are those three or some 4 or 5 types of IoT architecture? But I am going to focus on three important IoT architectures. It is a structured framework that defines how IoT devices, networks and applications interact to collect, process, transmit and utilize data. So in case of Amazon Alexa, we are saying that it takes the command, then send to the cloud, analyze it and execute it. But if you take the example of smartwatch, as I said, it doesn't send to the information to the cloud, it locally manages that information. Then for each IoT devices, there is a different architecture involved. Okay, so how that those IoT devices, networks and the applications, they interact to collect, process and this deliver the data, the actions or utilize the data. So there are different layers involved in that whole process, starting from the data collections and ending with you are executing that command. So it includes multiple layers that enable seamless communication between physical devices and your digital platform. So what are those IoT architecture types we are going to see? A well-structured IoT architecture ensures efficiency, less time, less cost, flexibility. Flexibility means there is some problem happened and then you want to make some changes in your network, or you want to very fast transfer the information, you can make those changes. Security in connected ecosystem. Suppose you have got the digital platform, whatever the AWS, Google Cloud, something you are doing it, you are transferring the huge amount of information, but there is that data is not secure. Then what is the use of that your IoT platform or all those things? That's why security in connected ecosystem is very important. So well-structured IoT architecture, what is the requirements of this IoT architecture? Scalable. What is it? Scalable means, suppose now in your company or supply chain, only couple of devices are there which are connected to your platform. But what happens if suppose number of devices increased? Do you think that your IoT platform will work? So that scalability should be there. It should handle the increasing devices and services efficiently. If it doesn't handle the increasing devices, services, then there will be a problem. So you need to focus on the scalability there. Interoperable, ensures seamless cooperation across different vendors. Sometimes you on the cloud you collect the information from the different your clients, and you process that data at one one location basically. So it should be that platform, it ensures the seamless cooperations across different vendors. Suppose there are 10 applications are there, and for that 10 application you are collecting the data from the thousands of sources. So your that platform should make sure that all those 10 applications are working fine. You are regularly communicating with those 10 applications. Distributive, enables data collection and processing in a decentralized manner. Cloud computing means it is a centralized. You are keeping the data in a centralized way, centralized location. But sometimes if you look at the smartwatch or the driverless car, you need that decentralized manner as well. Resource efficient, operates with minimal computing power. Okay, suppose you need the more computing power to analyze that data, it means you need more time, you need more cost to manage that one. That's why it should be resource efficient as well. Secure, again, prevents unauthorized access and ensure the data protection. If your data is leaked, there is no use of your IoT and all those things, because you collect all that huge amount of data. It could be from supplier end, distributor end, or demand side, and if that data is leaked, then it will be very problematic for your IoT platform. So common IoT architectures. So you can see here 3 examples. First one is the 3-layer architecture. Second one is the your SOA based architecture, middleware based architecture. Okay. So what is this 3-layer architecture? We will talk about that one first. Okay. So your first layer, perception layer. What is that perception layer? Any idea? No. Perception layer means your physical layer, where you collect the data, sense the data, and collect the data from the physical devices. That's your perception. What is network layer? Network, connecting. Again, you connect that data, transmit that data to the cloud, network layer. Okay, network technologies. Then application layer. Then after that, cloud, whatever the provider is there, it analyze, process the data, and it provides some insight in the form of application. Okay, different applications are there. It could be some application in your smartphones or somewhere else. Okay, so then that is your application layer. Perception layer, physical layer, that includes sensors, actuator, and connected objects. It collects the information. It collects the real world data. It could be temperature related, motion, RFID tags, location, all those things. Once you collect the data is collected. The network layer handles data transmission between devices and the systems, your IoT systems and the devices. So it handles that data, uses various communication technologies like Wi-Fi, 5G, Bluetooth, LoRa, and so on. Application layer, once the cloud analyze that data, process that data, then it provides. The application layer means software layer, where IoT services are implemented, provides user interaction, data visualization, and automation. So as I said, what kind of application you have in your smartphone or in your smartwatch or smart card, then you can see the the some dashboard or whatever the command you have given. On that basis you can see the basically the visualization in your application. So that's your 3-layer architecture. Then you have got this SOA based architecture. So what is that? Service oriented architecture, SOA. So we are going to see now. So what is the difference here compared with the previous 3-layer architecture? Service layer. What is service level layer? Sorry. Any guess? You are collecting the data. Network, you are handling the data between devices and system. Application, you are providing some dashboards there. So service level, it comes between your application and the network layer. Processing of information. Okay, yeah, that's correct. When you are getting the collecting the data and you are transferring, service level, it will see what information is important there, what is not, that collected data. It will analyze basically the data, and it will tell that what is the useful information data here before passing to the your cloud or before passing to the your application layer. Okay, trying to filter out some unnecessary or unuseful data or information there. A component based model connecting different functional units through interfaces and protocols. It enables reusability of software and hardware components. So service oriented architecture extends the traditional layer, as I said, perception network, by adding a service layer between the network and application layers. So key function of this service layer. First one is the service discovery, identifies the service request. So you ask Alexa, turn on the lights. Okay, you ask Alexa, turn on the lights. Alexa take that command, it gives to the cloud. Okay, before going to the cloud, there are many service requests are there. So it will identify which request you have asked them. Did you ask to turn on the light? Did you ask to turn on the AC? Did you ask them to turn on your smart TV? What you have asked. So service discovery, it identifies the service request. Then service composition, integrate services for efficient response. So they have got different kinds of the service requests. So based on our command, it will integrate the services for efficient response. Service management manages trust mechanisms for the requests. And the last one is service interfaces. It supports the interactions among the different kinds of services your application will provide. So these are the 4 applications. So service discovery, to find out, to identify the service requested by your user. Then service composition, prepare that service, integrate services for efficient response. Service management and service interfaces. The service layer enhances IoT architecture by offering flexible service coordination and management. Okay, so sometimes we don't need to transfer all the collected information directly to the cloud. We try to find out what kind of service is required, how you are going to select that service. So for that purpose, this service layer, it offers that flexibility of service coordination and management. Again, you can see all those 4 networks here, layers. Sensing layer, you can see data sensing and acquisition protocols. So you sense the data with the RFID tags, intelligent sensors, RFID. Then network layer, so you transfer that over the network. WLAN is their internet wireless sensor network. Service level, service discovery, service management, service interface, and then interface layer, basically your application front. Application front end, contract, interface, and application API. Middleware architecture, another third. What is the additional term added here? Middleware. Then what is the use of that middleware? Act as a bridge between applications, data, and users. So middleware, it is now updated from between the network layer when you transfer that data to the clouds, and the application layer again. It acts as a bridge between applications, data, and users. It ensures scalability, interoperability, and reliability of the IoT. Scalability, as I said, your IoT platform should handle the increasing number of devices and applications. So middleware, it helps for that scalability, interoperability, and reliability. It aggregates and filters data from different devices. Suppose you have got thousands of the trucks in your company, and thousands of IoT devices are there. Some small trucks are there, large trucks are there, delivery vans are there. Huge amount of data is coming from each vehicle and in different formats. So it helps to aggregate and filters data from the different devices. Performs the information discovery, again provides the access control to devices for applications. Which devices you need to provide the access for that application you can do. Advantages: supports the multiple application operating system and platforms. Again, it is more toward that application front end or application side. When you want different kinds of applications, you want for the different operating system or platforms, it supports these applications. Enable distributed computing across heterogeneous networks. Promotes interoperability through standard protocols and interfaces, and then simplifies integration of legacy technologies with new IoT solutions. Middleware simplifies IoT application development and promotes smooth integration and standardization. As I said, it helps you to create those different kind of applications, operating systems, and platforms, so that you could find out some insights based on the collected data. Then some of the other technology, RFID. Do you know the types of RFID? There are types of RFIDs as well. Does anybody know? Low frequency, high frequency, okay. Purpose of RFID is to identify, track, and transmit the information from one member to another member, or one entity to another entity. There are 5 main classes of RFID tags. Passive one, only passive tags with read and write memory. It doesn't interact with the other members. Passive adds security functionalities, additional functionalities. Third one is the battery powered, may include sensors. So there are some sensors you could add there in the semi-passive one. Active, battery operated, can communicate with the similar tags, other tags, RFID tags. Those RFID will active RFID communicates. Active, can activate other tags and connects directly to backend networks. What is the purpose of this can activate other tags? What do you mean? Active, can activate other tags and connects directly to backend networks. So basically, there is a one RFID tag active. So with the help of that tag, if whatever the data it is collecting, because of that you are taking the, or you want to activate the another tag, then you can do that here. Okay. Rohit, is tea there outside?
Yes.
Okay, 5 minutes. Okay. 5-15 minutes or now?
10 minutes break. 5 minutes.
But now, or you are saying?
No, after this, some call.
Okay. So Venkat, do you want to continue? Can you say if tea is there or not?
He is there.
He is there. Then we can take the break, because it's already 1.5 hours. So we'll take 10 minutes break and then we will continue again. Meanwhile, think some applications of this RFID in that 10 minutes break, and then come up with some applications and tell me where you can use this RFID. Like one example, Alexa, I have given. Give me some another examples from your day-to-day life, smartwatch or whatever other IoT devices you are using, or have you seen those kind of IoT devices in any company? Okay. Okay, we'll continue. Welcome back, students, and then we are going to continue our discussion on IoT technologies. We talked about the RFID. The purpose of RFID is to enable efficient and secure identification and tracking of objects across various applications. Suppose if you don't track the, where are your products, where are your trucks in your supply chain, so you cannot take the, the data-driven decisions, or you cannot plan things accordingly. Another important technology is WSN. What is this? Wireless sensor networks. A network of sensors used to monitor and track device status. Okay, so device status means whatever the like machine or your truck. So if you want to monitor the the performance of that machine, and then you want to track its status, you could do with this wireless sensors network. So it is a network of sensors that helps you to monitor and track the status of your device. It collects data on location, movement, temperature, and more. As I said, different kinds of the information we can collect, location related, where is the location of your delivery or your truck, what is the movement, temperature, those kind of things. Types of sensors in this normally used environmental. So if you want to find out the temperature inside your vehicle, you could use it. Air pollution or humidity, because for perishable nature of food, your fruits, vegetables, or those kind of perishable natures, you need to maintain the proper humidity of the temperature inside that vehicle. So it is a part of your cold chain logistics. Industrial pressure related, flow level related sensors, security and motion, proximity sensor, displacement, infrared sensors, others imaging and noise and speed related sensors are used to monitor and track the status of different devices in your supply chain. Sensors can cooperate and communicate with your RFID tags, because we looked at a couple of types of RFID tags. So there are from the tags, your traditional RFID tags, which are only read and write memory. Then we have some advanced RFID tags. They can collaborate, or they can engage with the other RFID tags. So these are these advanced tags, they can cooperate and communicate with the sensors, and then they manage the information accordingly. So you don't need to do anything. Suppose sensors takes the information from your physical devices. Based on that information, it will tell the the other your RFID tags. So what is the information, all those things. As I given the example of smart shelf in your smart warehouse, you don't need to order it. It will sometimes there are some smart freezers as well. I don't know whether have you heard or not. Smart freeze. So whatever the foods available in your freeze, if suppose stock level reduced, it will automatically place the online order. Whatever your Amazon or whatever the delivery partner you are using, it will automatically place the order. Okay, why? Because your milk is now you are running out of milk or something else. It will automatically place the order and you will get that order. So you don't need to do anything there. WSN play a key role in real-time monitoring and smart decision making in IoT application. Real-time monitoring, again, exact stock level, exact demand, and then sharing of that timely and accurate information with the other members of your supply chain. Then cloud computing. So what is the purpose of this cloud computing? So basically data collection, data transmission, and then third stage is data analysis, processing, analyzing. So cloud computing. So when you collect the data, you store, you manage on a cloud platform. There are different cloud service providers are there. For example, AWS. So cloud computing provides on-demand access to computing resources over the internet. For example, Netflix, YouTube. These are the parts of your cloud computing. So on-demand services, they provide huge amount of data they manage. It offers services like infrastructure as a service, platform as a service, software as a service. So based on the companies required, they provide the different options. So whether like sometimes software as a service, so you can rent the use the service software. You don't need to buy that software, or if you want to use their platform to do some data analysis, analytics related processors. So you can use their platform as well, sometimes their infrastructure as a service. Some of the key features of cloud computing: centralized data processing in remote sensors. They don't store the data locally. Alexa, all these IoT devices, they collect the data, they store somewhere in a remote location, means cloud, and then scalable and cost effective. Scalable means that cloud can handle multiple devices, multiple applications. That is scalable and cost effective as well. So as per your requirement, pay as you go, means how much you want to use that service. On that basis they will charge you. Provides high computing power and storage, so huge amount of data you can store there, and then they have got huge computing power as well. Used globally for applications like AI, storage, and business software. Challenges: high latency due to internet dependency. Have you understood this latency, or shall I repeat it again? What is that latency? Delay in transferring that information from your physical devices to the cloud. That's why I gave the example of a driverless car as well. Okay, suppose you detect that driverless car detected some object in front of that car, and if that IoT device is taking that information, collecting it, then transferring it to the cloud is analyzing and then sharing that information with you, there might be some delay in transferring and getting that information. So these are the challenges, like high latency due to internet dependency, due to huge amount of data, and security concerns over data privacy, because you are transferring over the internet, again huge amount of data, and because of this high latency there might be some security concerns. So these are the the challenges of this cloud computing. Then next one is the edge computing. Edge computing processes data closer to the source. Source means where the device, data source, or the device that you are using to collect the data. So here edge computing processes the data closer to the source instead of relying on a centralized cloud servers. Because of high latency and the security issues, sometimes, best example is the driverless car, you need to process the data locally. You don't need to send it to the cloud, and edge computing does that. It processes the data locally near at the edge of that your device. That's why it's called edge computing. It reduces the latency by handling computation on IoT devices or local nodes. Key features: low latency means less delay, real-time processing, reduces the bandwidth usage as well. You don't need to send it, then reduces the bandwidth usage by processing data locally. Works well in IoT, autonomous vehicles, and smart cities. So that these are some of the applications of your IoT devices. Challenges: limited computing power compared to cloud. Why? Limited power. Edge computing cannot handle the huge amount of data, because cloud, it can manage the huge amount of data. Security risk due to decentralized nature. You have got multiple IoT devices, and each IoT device is managing the information locally. So there is a problem with that one, security risk as well. Somebody can do the attack on that your locally manage the platform as well. So that kind of security risk are there. So these are the two important challenges: limited computing power and security risk. Because when you store the data centrally on a cloud, there is a low risk of any data breaches, or low risk of the the security risk when you store at the your cloud. But when you do this edge computing, decentralized nature, there is a risk of security. Fog computing, middle layer. Now you have got the cloud computing, now you have got the edge computing. In between that is called fog computing. Act as a middle layer between cloud and edge computing. Distributes computing, storage, networking closer to the data source, but not exactly at the data source. It improves the efficiency. Key features: balances between edge and cloud for optimized performance, reduces the data transfer and network congestion, suitable for industrial IoT. Industrial IoT means your manufacturing, logistics, warehouses, those kind of things. You don't need to manage the data at locally, and you don't need to send it to the cloud as well. So in between that, you can manage your data. So industrial level applications, you can use the fog computing, smart grids, and healthcare. Challenges: more complex to deploy than cloud. Cloud is easier to deploy, but fog computing is more complex. Higher maintenance cost than edge computing. Edge computing, you have decentralized nature. You can manage at local level, but here maintenance cost is higher compared with the edge computing. So now, what is the parametric comparison of these three technologies? Cloud, edge, and fog. So this is the parametric comparison. So first one is the architecture. Cloud computing, centralized architecture. Alexa takes your command, sends that command to the cloud. Cloud analyze, process that command, and then execute the whatever the command you have given. Centralized nature. Fog computing, edge computing, distributed nature. Distributed means driverless car, autonomous car, whatever the information, or your smartwatch. Okay, so locally they manage that information, process that information. They don't send it to the cloud. Data processing in cloud computing through internet, fog computing at fognet, edge computing near the source. Communication, cloud computing from long distance. Okay, from long distance, like whatever data we are taking here in Alexa, you transfer it to the cloud. And then fog computing direct with fog node, edge computing at network is latency. In cloud high, fog low, edge low. Computing ability again in cloud it is higher, fog and it is lower, but edge computing it is middle level. So whatever the middle level information you are getting from your sensors, actuators, you can use it. Scalability, cloud computing easy to scale. Fog complex, and then edge is easier than fog. Response time, cloud computing minutes, fog milliseconds, and edge computing seconds. So within seconds, suppose that driverless car detects something, within seconds it will apply the brake or it will change the direction. Some actions it will be taken. Hops to server, multiple, one depends on the application. Bandwidth utilization, cloud computing high, fog computing lower than cloud, and edge computing significantly reduced. Security related, cloud computing less secured, here fog computing more secured than cloud. Scope, cloud computing you can use globally, you can store from data from any sources anywhere. Fog limited, and edge computing application dependent, whether you are using that fog computing in driverless car or some other applications, so it depends on that one. Yes, go on.
Earlier it was mentioned now that edge computing is less secure due to decentralization, but here it is more secure than cloud.
Which one?
If you see the security parameter and see the comparison between cloud computing and edge computing.
Mm-hmm.
So in previous slides we saw like edge computing is less secure because of decentralization.
Yeah, that's correct. So yeah, there is some problem with this one. That's correct. So cloud is more secure, that one, and the edge is that is the one I told you in the last one. Am I right? Security risk due to decentralized nature. Yeah, that's true. So I think this second last, there is some problem with this second last row. Good observation. So cloud is more secure, edge is the less secure because of the decentralized nature. Then this is the basically the overall comparison. Cloud computing is best for large scale application requiring high processing. So your thousands of cloud servers are there, data centers are there. So for that large scale applications, large scale data, you use the cloud. Then you have got in between last stage is your edge. Edge computing is ideal for real-time application where low latency is crucial. You don't want any delay in executing your command, in executing, analyzing that data. So that's why your edge computing. Then, sorry, your fog computing balances between the cloud and edge and optimizing efficiency and cost. So that's your fog computing. Representative list of IoT platforms. So AWS, everybody knows this one. Then there are some other platforms are there. Cisco IoT, Microsoft Azure, Oracle IoT, SAP, and ThingWorks. Okay, and you can see what is the connectivity, what is the security level, event monitoring, and what kind of algorithms does it use. Role of IoT in supply chain management. Now we have talked the what is IoT, what are the types of IoT, then technology used in each stage like data collection, data transmission, data analysis, and then your data execution. So now we are going to see some of the applications or where we can use the IoT devices in supply chain management. Okay. First thing is the source starting with the supplier. So link with sub-tier vendors. I gave the example of Boeing 787. Boeing tried to use the digital platform, RFID or some other platform to get the timely and accurate information from the tier 1, tier 2 suppliers, but they didn't upload that information. That's why they faced some delays. So you can link with the sub-tier vendor. So you need to ask all your vendor suppliers that use these IoT devices, so that these IoT devices will be connected to the cloud, and then manufacturer will get all the information available. Real-time progress and inspection data from vendor. Real-time progress means you don't know when you will receive the delivery from your supplier. So suppose supplier is making the order what that you have sent to them. So you can find out the real-time information. Okay, how much products they have made, raw material components, how much stock is available in their warehouse, in supplier's factory, when you can expect the delivery from them. Then supply chain data collection as well. Again, quality, lead time, so many other KPIs related data you can collect from that source, basically supplier side, with the help of IoT. And what will be the impact of this? Then trying to find the real-time information from the supplier. More visibility in supply chain. You can find out the bigger picture. Basically, you can look at the small the details in your tier 1, tier 2, tier 3 supply chains. More visibility in supply chain, improve quality and reduce lead time. Reduce lead time because they are using these IoT devices, sharing the timely information with you, so that it helps to reduce the lead time, improve the quality as well. Better quality at lower cost. Because of IoT devices, they are doing the preventive maintenance that will reduce their downtime, that will reduce their machine breakdown, and it helps them to reduce the cost as well and provide the quality products. Strategic planning for supplier selection and product assortment and differentiation. So basically, when you go with this supplier selection, you consider the cost, quality, lead time, some other criteria. So you could do that strategic planning, or the impact you can see of this IoT on the strategic planning as well when you do the supplier selections, because you can analyze all this data, quality related data, whatever the data they are sharing, because you are automatically trying to get that real-time information with the help of IoT, and it will help you to get. Suppose in case of that Nokia Ericsson case, suppose the Nokia and Ericsson, if they were using the IoT in the Philips plant, they didn't need to ask the Philips like to tell us what happened. They should have got the information directly from their IoT devices. As something happened there, and then we may face problem. But in normal cases, they need to call the supplier. They need to ask them what's happened, why is there is a delay in the delivering the products. So that those kind of problems we could manage with the help of IoT. Then make means manufacturing plant. Visibility on more parts and raw materials, like how many parts we need or raw materials to make those finished products. Combine product and after sales service. How can we combine product and after sales service? Any example? Suppose you are selling one product, finished product, you can use some IoT devices on that one. When it will go to the customer, you can track the performance of that your sold product, and you can propose some preventive maintenance, so that you can combine product and after sales service as well. You can ask your the customer that this product needs the service. Why? Because our IoT
Given the example of that car.
Yes.
Sensors,
Ye-
there.
yes. So Rolls Royce and so many other automotive manufacturers, they are nowadays using the IoT devices. Then combine product, that's done real time quality and maintenance data from customer. Maintenance data, as I said, if suppose you are buying a car from somebody, so they you can use the IoT devices. It will tell you the how you are driving the car, when that car needs the maintenance, all those things. Remote preventive maintenance. So you can do the remote preventive maintenance. Means, do you know remote preventive maintenance? Preventive maintenance, but remote. You don't need to go there to actually do that maintenance. Suppose you have got you sold the car. On that car some IoT devices are there. You can operate those IoT devices from your factory. Operate means, suppose something is going wrong, the supplier, the customer will call you, something happened here. You can use the IoT devices data, and you can sort out that problem without visiting that factory, or without visiting that customer. So remote preventive maintenance. What are the impacts? It reduces lead time and cost, because you are improving the visibility in your factory. Okay, you are trying to avoid the maintenance there, costly maintenance. Increases the revenue, improve the product design and time to markets. So when you get the improved visibility in your product development, it will help you to reduce the development time as well, and product design as well. Increase product life and customer satisfaction. Why product life? Because you are doing the preventive maintenance of those sold products, and then you are avoiding some costly failure. That's why your customers will be happy as well. So that's why it increases the product life and customer satisfaction level as well. Then next one is the deliver stage. Inventory tracking and information sharing and joint ordering. Suppose if you want to share the information about your stock demand, the IoT helps for that one. Inventory tracking as well. Smart shelf example, it will automatically share the information about the inventory available in that warehouse. Autonomous decision making, another example, driverless car. Quality monitoring and quality controlled logistics. So basically during the cold chain logistics, you can maintain the temperature. Normally we think that we can just get to know about the temperature within that the temperature inside that truck, but now some advanced IoT devices, you can manage the temperature inside that vehicle as well. Okay, suppose if you think that temperature is increasing little bit, you can reduce the temperature as well. Impact significant time savings and real-time visibility, efficient use of space and resources, like optimum use of your vehicle's capacity, collaborative warehousing, timely delivery, increase the inventory of accuracy, and reduce the shrinkage and misplacement. Shrinkage during this perishable nature of products, and misplacement as well. Saves time, it saves space and money, improve the quality standards and reduce waste. I will give you one good example of this delivery. Why? Because currently I am working with one company, it's called Tower Logistics, a tower cold chain solution. This company rents the reusable containers to the pharmaceutical. Okay, so the pharmaceutical companies, they take these reusable containers, and these reusable temperature sensitive containers, they are used to transfer the temperature sensitive products, pharmaceuticals, from one point to another point. So currently they are trying to use the IoT devices, Internet of Things devices, to track the location of those reusable containers, where are they located in their whole network, and so that they can optimize their network. That's the one example of the how we can use the IoT devices to track the product or the other things in the supply chain. Return, it enhances the reverse logistics. Suppose you order something from Amazon, now you want to return it. IoT device, it will tell you, okay, where is that product in the return logistics, where it is coming back, why is it coming back, more traceability, capturing product data while in use. Capturing product data while in use. Suppose you order something, you are using it, so it will capture that data as well sometimes nowadays. It reduces the cost and lead time. It reduces the cost, increase the customer satisfaction. Let me see, this is a video, if I can turn it on.
Manufacturers and supply chains. Supply chains consist of many different partners, from manufacturers and distributors to hauliers and retailers.
Look at this one example of
Each part
how
of the
we can
chain
use the
can
Internet
become
of Things.
vulnerable to disruption. And without access to real-time traceable information, it can be difficult to plan for or respond to problems.
This is an example of Vessel. Suppose when Vessel is bringing the products of the different, the importers, how the ports, the hauliers, they can manage their
Things provides
resources.
the opportunity for supply chains to become more connected, and for partners in the supply chain to improve their planning and performance. Let's look at an example. This vessel is about to arrive in a UK port. It's full of containers with goods ordered by different importers. A bay plan maps out the current location of all the containers on board.
What could happen, suppose if you don't get suppose there is a one vessel, that vessel is bringing the different products ordered by the importers. So why do you need to share the expected delivery time of arrival to the port so that they can manage their resources properly? Because there are not that only one vessel is coming at that airport, that port. So many other vessels, ships are coming. They need to manage their resources so that they can reduce the cost, time, and everything. So they will see, how many vessels are already at that port. When this vessel is going to come there, accordingly they need to contact the, the hauliers as well, the road freight transporters as well, who is going to bring, take those products from that ship to the importers. So if all this information, the vessel is there, port is there, and then hauliers, the transportation, company, logistics managing company, if all these members, they are getting the, the real-time information from these IoT devices. Suppose there is a delay happening in that vessel, okay, so the vessel arrival. So then the port can use the whatever the berth available for that vessel for other ships until the vessel comes to the port. Similarly, the logistics manager, the logistics company, they can use the fleet vehicles for the other purposes. Simple another example of when you go to the fly when you travel with the train or flight, normally before going to the station we check the status of that flight or train. Why? Because we don't want to unnecessarily go there and wait if that flight or train is delayed. Okay, that's the example purpose.
The haulier, due to pick up the containers from port and deliver them to a warehouse, has a fleet ready and waiting. But without access to up-to-date data on a vessel's estimated time of arrival and bay plan, the port cannot plan the unloading optimally, and the haulier cannot plan its fleet until the vessel docks. They won't know when the container is cleared by customs to be collected.
Custom clearance is another very big thing
This
at the
can lead
port.
to long waiting and traffic congestion at the port. Disruptions then spread along the supply chain to the importer, who now...
If suppose there is a delay happen at this port when entering that vessel, it will affect these hauliers, then the other logistics
Faces delays.
provider in that there.
But by creating an IoT data integration platform where the port, the vessels, the haulier and the importer input their information in real time, everyone can have a clearer view of the situation, meaning decisions can be made much more effectively. For the haulier, they can book container pickup slots before the vessel arrives. The slots are constantly updated, reflecting the container's readiness. As for the port, they can stack containers in reasonable locations in the ensures more goods are delivered on.
Why is it not working this down? This is the problem when we try to run the play the video in the slide presentation. Now look at the, why is it saying? Look at the now driverless cars in San Francisco, and this is already happening, and look at how it is.
So much emerging technology is just a show, so one can be forgiven for not being able to distinguish fact from fiction. Take this car, for example. Can it drive
Are you able to hear it
autonomously
properly?
or not?
The short answer is absolutely.
That was
Waymo
Shweta
is the Google's
Srivastava,
company which
Senior
made
Product
this.
Lead for Driving Behavior at Waymo.
What you're looking at is the Waymo driver in action. Adapted for a variety of vehicle platforms, it is the most advanced, fully autonomous driving technology in the world today.
What you notice pretty quickly is that these aren't normal vehicles. Take this Jaguar I-Pace, for example. It's been equipped with an elegant array of sensors and software,
You can see
which
how
allows it to
many
move
IoT devices are attached to this car.
through the city on its own.
That's correct. The Waymo driver is a combination of custom-designed hardware and software that is responsible for performing the entire act of driving.
That was James Philbin. He's an engineering lead on the perception team at Waymo. I asked him to break down the technology for us a bit more.
The Waymo driver handles the task of driving in 3 basic steps: sense,
Sense,
solve,
solve,
and go.
basically sensing the data.
It's the way we
and
describe the highly complex process of acquiring information, processing it, and moving through the world safely.
So, what goes into all that sensing?
The sensors that the Waymo driver uses are incredibly powerful, using a combination of LiDAR, cameras, and radar. It can see up to 3 football fields in any direction.
Look at their the accuracy. 3 football the areas they can see the basic
And can
sensors.
detect sirens from emergency vehicles,
It
which
can detect sirens from any
allows the
emergency.
Waymo driver to visualize the world around it in milliseconds to a high degree of accuracy.
Okay, sense makes sense. But what do you do with all that data?
Good question. The system calculates the predicted future behavior for each relevant agent in the scene. Then, with a strong foundation derived from artificial intelligence and machine learning algorithms, the Waymo driver crunches all that data and calculates a safe route, while responding in real time to the evolving traffic environment.
If I understand correctly, this means the Waymo driver continues to learn as it goes, is trained and tested on scenarios that it's never seen before, and can differentiate safe and comfortable driving behaviors from hazardous and uncomfortable ones.
Yes, well done.
Why, thank you. The final step in the Sense, Solve, Go methodology is perhaps the most straightforward. Go.
Once the Waymo driver has determined the path to take, our advanced motion control systems allow for smooth acceleration and braking on hilly streets, or managing bumper-to-bumper traffic with safe and natural driving movements.
So it's really here, right now in cities. Not smoke and mirrors, but true autonomous driving technology. Waymo is taking what was once futuristic sci-fi and making it nonfiction. And like all great technology, all that number crunching, all that data just fades into the background. And you realize the dream of riding in a fully autonomous vehicle to your favorite dinner spot isn't just a vision of the future. It's actually happening right now.
How was it? Good. So this is really happening basically in San Francisco and other parts of the US. They have around like 700 or 1,000 cars are running, and the overall cost is also reduced. Why? Because there is no driver. There is no driver cost involved. You simply order that Waymo car. Then how to open that one, basically you can see on the YouTube as well. If you just see some videos, you open with the help of your that app, you will get the code, open the door, enter it. Once you enter into that car, then there is a screen as well. Just activate go, everything is set. Then it will ask you to wear the belt as well. Unless and until belt is wear, it will not start. And then it will drive as a human being drives. I would say more than that, accuracy wise. Suppose there is some the road is closer, it will take the another route and it will take you there your spot. So this is the case where you can see how IoT devices can help to improve those processes, operations, and then overall it will be beneficial for the everybody. So now some of the use cases we will see here. Again, I think slide presentation stopped working. Okay. So here one pest control company deployed a fully automatic solution that uses the cellular connectivity to continuously monitor and control the pest activity. So normal traditional operations you can convert with the help of these IoT devices in a digital format, so that to streamline those operations, reduce the time, cost. So this company's pest control activity, they converted into the digital form, basically with the help of IoT devices. These solutions features made it more effective for customers than conventional pest control services and was highly profitable for the provider. Ultimately, the IoT tool replaced the standard physical, what happened? Okay. The IoT tool replaced the standard physical and manual pest control tools, avoided the use of pesticide and generated data and documents required for regulatory compliance. Yesterday, I think, not yesterday, day before yesterday, Lohit was talking about, Lohit from IIT Hyderabad, he was talking about how this advanced artificial intelligence you could use for the for regulatory compliance, for creating those things. So these pest control company, they use this tool to replace the standard physical and manual pest control tools, whatever the documents they were generating. So they use these IoT tools, avoided the use of pesticide, generated data and documents. Another one, specialty company used a suite of IoT solution to improve its manufacturing and supply chain performance. The company was able to track the overall equipment effectiveness online. So all the machineries performance you can check online. You don't need to go and visit that machine's performance, eliminating bottlenecks in its operation, which led to significantly improved output. Facility condition monitoring. Facility condition monitoring, suppose you are running a warehouse distribution center, and if you are keeping the fruits and vegetable perishable nature, so you need to make sure that the humidity, the temperature inside that warehouse should be in a good level to accommodate that your perishable nature of products. So manually you cannot go there in each corner and check the humidity and pressure. Okay, whatever the measurement that you are going to use. So challenges: manual, time consuming environmental monitoring in warehouse. Delays in detecting temperature and humidity variations. As I said, you cannot go in each and every corner of that warehouse to check your temperature, humidity level. You need some advanced technology that will detect the temperature and the humidity variations within your warehouse. IoT solution. This LPWAN enables sensors provide the real-time data. It automatically alerts to the customers for condition deviations. centralized platform for continuous monitoring. Business impact, it will reduce the time and resources, basically cost, resources saving through automation, improve decision making for warehouse maintenance. As I said, you don't need 10 member of employees to check the humidity and the temperature level. Better product protection across supply chain. Cold chain monitoring, if you are moving the goods in a cold chain vehicle and your focus is to maintain. So for example, COVID-19, what was the temperature requirement? Pfizer, minus 70 to minus 80 degree. In developing countries, it is very difficult to maintain that much temperature. And if you use those contaminated vaccines, it is very dangerous for the people's lives. So you need to logistics, that cold chain logistics is very, very important. And without the help of this IoT, you cannot make sure that whether that vaccine is exposed to the outside temperature or not. So COVID-19 vaccines required ultra cold transport. Pharmaceutical products again need strict temperature control. Those kind of for challenges you can use the IoT devices. Lack of real-time visibility on shipment condition. IoT solution, connected sensor track shipments end to end. So you are not only using one sensor, you are using couple of sensors. They are connected to each other. They send the information about the temperature, humidity, all these the requirements for the pharmaceutical products. Automated alerts flag temperature deviation. Real-time reporting ensures compliance and audit readiness. So nowadays, if you scan any QR code, it will tell you what is the temperature available at each point during the journey of this product, and it will tell you as well sometimes where it is exposed to the outside temperature. Business impact ensures product stability and safety. Product safety is very important in pharmaceutical nature, pharmaceutical sector or your food sector. So in order to maintain that, you need to use these things. Improves logistics efficiency and transparency. Supports growing demand for temperature sensitive shipments. Shipment monitoring for security and loss prevention. Again, challenge is lack of real-time visibility in supply chain. So sometimes high-value products, electronic products, they are normally the target of the thieves. So you can use these IoT devices to track those kind of shipments. Lack of real-time visibility challenges like risk of theft, tampering, and environmental damage of those high-value products. Traditional GPS trackers had size and battery limitations, so you could use GPS-enabled device track shipments from end to end. Smart sensors detect temperature, humidity, light, and variation. Light sensors flag potential tampering or package damage. So there are many kinds of sensors are there. It based on your requirements, whether you want to focus on the its appearance, temperature, humidity, what do you want to measure. So those kind of sensors you could use. Business impact prevents theft and loss, improving the security. When somebody is trying to steal the products, or sometimes somebody is trying to enter into your vehicle, it will tell you that send some notifications to the customers, clients. It enables quality control in transit, supports investigations and recovery of stolen goods as well. If suppose GPS IoT device is attached to that product and somebody steals that product, so it will help you to find out that product as well. Connected home, as I told you, you can see window control is there, smart living, smart TV, smart lighting, thermostat, smart is your AC, then smart watch, wearable devices, everything is connected to the internet. Okay, just you need to give the command, Alexa, turn on the light, turn on the curtain, turn on the AC, everything is connected. Then so IoT enables smart parking. As I told you this example already. Suppose in metro cities now everybody is facing this parking problem. So if you have got some empty spaces and you want to make sure it improves so that everybody can get some benefits, that's one. You can connect those spaces over the internet, like you can connect those parking spaces. You can use some parking meters there, and the IoT devices on that parking meters, that parking spaces, you can use some cameras to find out the empty locations. New data is generated, with the help of those IoT devices, which will help you to find out the space availability. Then process innovation, based on the available spaces you can find out the pricing as well, payment, finding spaces, and this will help you for the traffic wardens, citizens, drivers, city planners. So many things we could do with the help of these IoT devices if we use them properly. Capabilities, it will monitor the performance, then tell you to when we need the preventive maintenance, measure the again performance, control sometimes the temperature inside your vehicle, automate the things, optimize as well, and it learns from the previous experience. Basically sometimes Alexa it learns from your previous commands, and then accordingly recommend some options. So those kind of capabilities you can see in the IoT enabled platform. Some of the best practices of this IoT to improve the operational efficiency. Traffic and fleet management. So these are the real cases. So TOPIS is a model for future smart cities integrating IoT and AI to improve the urban mobility. So actually in South Korea, Seoul city transportation, they are using this TOPIS, manages the public transportation. So they started as a bus management system in 2004, now covers all transportation except traffic signals. It enhances the urban mobility through real-time data collection. So they integrated the IoT, they are using the artificial intelligence to capture the data available from each corner of the city based on the traffic flow, congestion, and all those things. And they are planning the transportation systems. How it works? Basically, data sources they captured from the GPS location, loop detectors, video feeds, road sensors are there. So many things, yeah. GPS are there, yeah. Video feeds, road sensors are there, citizen reports. Then they monitor the buses, taxis, streets, citizens' feedback for dynamic traffic management. Do you know when you use the Google map and when you see some accident happen here, you can report that accident onto the Google map. So it gets updated. When somebody is following you, he can say that, okay, some accident happened there, that's why traffic is building. So that's why citizen reports, all those things. Uses AI and big data to optimize the transport policies. Some of the key features of their model, you can see here. Real-time bus and traffic information. You can find out because GPS, IoT devices are attached to those vehicles, so you can find out what is the location, when you can expect that bus there. Travelers access live arrival times via apps and screens. Reduce traffic congestion. If there is a traffic congestion on one route, it suggests you to take the another route. Optimize bus routes and efficient transport flow. Enhance public safety, AI-based incident detection and response. Improved commuter experience, clear communication, increases transport service intake, and higher customer satisfaction because of reliable, efficient, and user-friendly transit system. If I am getting all the updates as a customer, as a citizen, if I am getting all the updates about my bus, about my train, about my flight, and then on that basis I am making my decisions, so everybody will be happy. So that's why reliable, efficient, and user-friendly transit system.
Will be more efficient for emergency vehicles like
Ambulance.
fire brigades?
Yes, that's true. Because we
हट लेके जाते हैं ना ट्रैवलर वो ड्राइव सिनेरियो
yes, because these emergency services, they need to reach to their the affected area very fast. So this will be really helpful to find out that the optimal route or best route. Smart fleet management at the port. So we just looked at one video. So you can see one example of Hamburg, Europe's second busiest port. They are using some IoT and AI devices to boost the efficient supports future growth. Goals is to modernize the IT infrastructure, enhance operations, and reduce the traffic impact. IoT powered fleet management. So all the the ships and then cranes, all those devices are connected to the internet connected system. It integrates ships, rail, road traffic for seamless coordination. So when you know what is the expected arrival time of your ship, accordingly you manage your hauliers, road transportation, rail transportation. So everybody is trying to share the information and they are working together with the help of IoT devices to make this the seamless or the streamline the processes or operations. Traffic monitoring, 300 plus roadway sensors track vehicle flow and detect the breeze wear. Smart traffic solution, digital signs and mobile apps provide real-time parking and traffic updates. Waterway coordination, again, a radar and automatic ID systems manage the ship movement. So they are not only trying to focus on the road, they are also trying to enhance their the waterway transportation, then air freight transportation, bridge traffic integration, predicts and manage the disruption from ship-related closures. Key benefits: optimized transport flow, reduces the congestion and improves the logistics, enhanced the port operations, real-time data. It ensures the efficient resource allocation. They minimize their ideal time, the cost and time. Better traffic management reduces the delays for businesses and commuters. Sustainable and smart growth supports economic expansion with minimal local impact. So these are some of the benefits of smart fleet management, and you can see how Hamburg they are using these smart technologies to enhance their operations and reduce the traffic impact. Warehousing, you can see some example here. Okay, so a forklift truck workers, people they are coming, so warning pedestrians are ahead. Outbound delivery order, you can see here, status is complete, condition okay, smart lighting is there, warning hazardous and heavy item load center not achieved. So you can see the some the basically the information about each and every product because of these smart devices and the IoT devices. Enhancing efficiency and accuracy, optimize space utilization. IoT enables real-time tracking of goods for efficient storage and retrieval. Okay, so in warehouse you can use the IoT devices. Suppose if you want to optimize your warehouse or efficiently reduce the unnecessary movements, you can use those devices based on the information available in that IoT devices. You can find out what is inside that one. Smart inventory management, RFID and sensors automate stock tracking, preventing shortages and errors. So as I said, smart shelves are there. They track the on-hand inventory, and accordingly they manage the Kanban signals. Yeah, the replenishment. Automated damage detection. Cameras scan incoming goods. Like Venkat, you said that cameras they detect whether there is a damage on your product or not, and accordingly they manage. Reducing manual inspection. Connected assets and predictive maintenance, real-time asset monitoring, like sensors track forklift trucks, conveyors and AGVs to maximize the utilizations. So real-time asset monitoring we can do with the IoT. Predictive maintenance, monitor stress and wear on machinery, preventing breakdowns. So if you find out some information about the stress wear on that machinery with the help of IoT devices, it will provide you the schedule for the maintenance as well, and you accordingly we do the maintenance, and that will help you to prevent the breakdowns. Indoor GPS for forklifts, switch lock smart lift tech improves navigation, boosting efficiency. So you can see that here on the smart on the forklift trucks as well, there are IoT devices are available, and they will detect what is behind and what is coming from their other ends and what is inside in that the box as well. Like status gearbox requires immediate maintenance, like this is for that maintenance, but IoT devices is also attached to this box as well, and it will tell you what is inside that one. Workforce safety and accident prevention. So collision avoidance, forklifts use radar and cameras to detect obstacles and prevent accidents. So similar to our just a second. Okay. Cameras to detect obstacles and prevent accidents. Load stability sensor, smart forks detect imbalance or overweight pallets, reducing mishaps. Smart pallets, if there is an imbalance onto that the while loading or unloading that pallets, so it will tell you that the pallet is not properly loaded or loaded, and then similarly it could happen with the your smart forklift trucks as well. wearable tech for workers, smart glasses and RFID tracking enhance efficiency and safety. If workers, they are not doing their job properly, if they are not getting the working condition is not good, so everything you can check with the wearable technology, how they are moving their hands, what kind of actions they are taking when they are picking something or they are doing some actions, and based on that, and then you can do some analysis, and you can say that how could we improve their efficiency. Those kind of activities we could do with the wearable technology for workers. Sustainability in energy management, any idea? Sustainability in energy management, how could we use? Suppose I want to find out my carbon emission, CO2 emission. Can I use the IoT devices? Tell me, how can I use the IoT devices?
In our IT main building,
Sensor-based lights are there. So because of that sensor-based lights, they will automatically turn on based on the the presence of the people. So that's the one thing. What else? Smart energy optimization, IoT controls lighting, HVAC utilities, and cutting cost and emissions. You can find out the emissions. You can find out the emissions of vehicles with the help of IoT devices as well. Reduce the carbon footprint. Automation improves efficiency, minimizing waste and energy use. There are so many benefits. This is only the warehouse. If you look at the supplier side, manufacturing, at each node in your supply chain, there are many applications of this technology. Freight transportation, next generation tracking and security. So you can see that here, when your vessel arrives at your ship, what happens, it will tell you what is the temperature of this container inside, what is the humidity level, light container opened for custom, shock, no shock events detected. So this kind of information you can get. And then here you can see engine sensor, flight, engine sensor status, serious malfunction detected, action, maintenance team ahead, okay, alerted. Then shipment, here shipment, you can see location, what is the ID, speed, what is the ETA, expected time of arrival, medical damage, likely maintenance checks, scheduled. And again you can see the performance of the vehicles as well. You can find out overall the maintenance requirement for that vehicle as well. Real-time tracking, IoT allows second-by-second location monitoring for freight across air, land and sea. Second-by-second location. Because of this real-time tracking, you get everything, all information available from your freight transportation mode, air, land, sea, everything. Enhanced security. Telematic sensor detect unauthorized package opening and theft risk. So these are the technologies that will tell you who has opened your package and what happened there. Fleet visibility, open platforms like Agira integrate various tracking devices for end-to-end supply chain monitoring. So starting from your tier 2, tier 3 or original suppliers until your end customers, you can track the the visibility of your fleets. Fleet and asset management, optimal utilization. Sensor track vehicle load capacity. Suppose your vehicle load is 50 ton and you are moving with only the 20 ton, and your driver is saying that no, we have got the full truck load capacity. Okay, so you can, with the help of GPS, we can find out whether what is the exact load available into your vehicle and how much we can add into that. Suggest route optimization to reduce empty miles as well. Empty miles means you are running your vehicles without any load, so it will suggest you can take the different routes, or that you may get some demand from that route. Predictive maintenance, smart sensors analyze vehicle health and schedule repairs proactively. So this is the one as I shown you here. Damage. Predictive maintenance, it will analyze the performance of your vehicle, monitor the performance, and it will tell you that whether this vehicle needs any preventive maintenance or not. Increase uptime. IoT driven maintenance improves vehicle availability by up to 30%. Okay, so you can basically reduce your vehicles downtime, unexpected breakdown with the help of this IoT driven technologies. Driver safety and risk management, fatigue monitoring. I told you in Japan and some other countries they are using the IoT devices, cameras, And if you just driver is feeling sleepy or fatigued, then the bus will not start. So cameras analyze driver alertness and activate alarms if fatigue is detected. Caterpillar's AI system is there. Collision prevention sensors and camera help avoid accidents by monitoring blind spots and road hazards. So sensors are there. Nowadays 360 sensors are coming. So you don't know what's coming from your left hand side or right hand side. With the help of those 360 degree sensors, you can find out those blind spots and road hazards. Disasters and disruption management. Tools like DHL Resilience assess the global risk and adjust supply chain strategy in real time. Sometimes you can use the IoT devices. It captures the different kinds of data, as I said. The global events happening, what is this Red Sea crisis or the Suez Canal. So based on that data, these IoT devices sometimes will help you to predict the disasters or any unexpected event as well. IoT is revolutionizing freight transport with enhanced tracking, efficiency and safety. Last mile delivery, any idea? What are the applications of last mile delivery? Drone, yeah, for last mile delivery to deliver your products. Then what else? Lockers, yeah, again. Lockers, you might have seen only the normal Amazon's locker. But what if suppose your product is perishable in nature? You cannot keep into that locker. What is else? So that is called yes. So yeah, those kind of lockers are there based on your requirement, like that will maintain the temperature of the vehicle. Sorry, that product. Connected mailboxes sensor detect when mail or parcels arrive and notify the recipient. Suppose your mailbox is connected to the internet, then whenever something comes, it will tell you a new parcel came or new letter came. Parcel lockers, temperature control, smart lockers ensure secure and first time deliveries. And already this is happening, guys. It's not like that. This is not the future. This is already happening. Route optimization, real-time mailbox status data reduces unnecessary stops for couriers. Flexible and anticipatory deliveries, smart homes and replenishment. IoT-enabled fridges and stores automatically order items before they run out. I already told you. IoT-enabled fridges and stores, they automatically orders the items. You don't need to tell them that, do the order. They will automatically place the orders. Dynamic delivery addressing. Proximity sensors and location data allow real-time delivery address changes. Okay. Sometimes if you order something from the Uber or whatever it may be, so the delivery boy can track your location. Okay, and if you change your locations, they will follow you. So those kind of dynamic delivery addressing. Amazon's anticipatory shipping. Predictive analytics move expected purchases closer to the consumers before they even order. So before the order, sometimes they do this predictive analytics, move expected purchases closer to the consumers before they can order. Last mile delivery, again, monetizing return trips and on-demand shipping. On-demand pickups. Services like Ship allow users to send packages simply by taking a picture and requesting the pickup. Those kind of, advanced stuffs some platforms are using. Optimized reverse logistics. Couriers can pick up the return shipments dynamically based on their real-time route. So when you are returning something, so the delivery partners, they sometimes, if some delivery vans, they are going through your route, they will automatically, not automatically, they will ask you, can we pick up those orders. Those kind of optimized reverse logistics. Item level tracking and transparency. RFID and smart labels. NFC enabled packaging tracks temperature, humidity, integrity of perishable or sensitive items. So you can basically track and trace each and every information or that product with the help of IoT devices. Perishable goods monitoring. Consumers can verify if chocolates, poultry or pharmaceutical were stored correctly during transit. If you are ordering some temperature sensitive products and you want to check whether the delivery partners, they have kept it properly or not. You can do that as well. IoT devices will tell you. Smart packaging. Companies like Thin Film and Diageo are experimenting with smart labels that provide authentication and product details. So this is another example of this technology, smart packaging. And these are the ecosystem, basically connected homes and consumers, smart cities infrastructure. There are many applications in retail, healthcare sector, agriculture, energy, manufacturing. Can you tell me the applications of IoT in agricultural sector? Any idea how could we use the IoT devices? Smart irrigation systems. Okay, that's the one. Anything else? Irrigation is one. Anything? Have you heard this precision agricultural term? What is it? Yeah, you can detect the weeds as well, yeah.
Precision agriculture is like using the exact number of things, like whatever resources is required,
Mhm.
we'll only use that much, so that we are not overdoing it.
But how could we do that?
Using multiple sensors, like there are soil moisture sensors,
Hmm.
then again pH sensors as well,
Hmm.
and temperature sensors as well. So we can use all these technologies, and it can also be used in vertical farming as well.
Yes.
For aquaponics and all.
Yes. That's the correct.
Pesticide is required.
How much pesticide? So that is called your precision agriculture, or basically the use of all these the sensors. How much water is needed, how much whatever the fertilizer, all those things needed. Unnecessary. If you look at the traditionally your farming, we don't basically find out what is needed for that crop. We randomly give the water, fertilizers. So when you find out how much is needed and you give that much of amount to that the crops, obviously productivity will increase. So that is a the example of your precision agriculture. Manufacturing, we already talked about. Security, surveillance, public and private transportation, we talked about the case of Seoul and some other examples. Have you heard this term, guys? Truck platooning? Anyone? Tell me, suppose there is a two scenario. One scenario, one truck is moving on the road. Another is 4-5 connected, digitally connected trucks are moving. What are the benefits of these digitally connected trucks, and what is the benefit of this 1 or 5 trucks? They are driving individually, or they are running individually, not connected. What is this truck platooning? So truck platooning is the linking of 2 or more trucks in a convoy using connectivity technology and automated driving support system. Suppose there are 3 trucks, and the second and third truck, those trucks will follow your leader, the main trucks. Okay, so already now this technology has already tested in some countries, but they are not basically following it at the moment. They have tested, they have got all the green signals and everything, but there is a time needed to basically like driverless cars. Driverless cars, it is already happening. This technology has already tested by Volvo and some other companies, and it will be coming in the near future. So basically the benefits of when you drive these vehicles in a connected manner, first there are many benefits. What are those benefits are there? You can see that you could reduce the time, the speed, and then that resistance is not there. So basically it uses the technology. There is a leader truck, then followers are there. These vehicles automatically maintain a set close distance between each other when they are connected for certain parts of journey, for instance on motorways. So these trucks, they are not connected from the whole journey. It depends on you. When you want to connect them, you can disengage them as well. Suppose on a motorways, you know that there is a straight route is there, and you want to connect them, you connect them, and then the drivers, the drivers in second and third trucks, they don't need to do anything else. They need to sit there and they do whatever work they have to do. Okay, so that's the use. But basically, because the resistance, whatever the air resistance is very less compared with if they are running individually, it helps them to reduce the fuel consumption and then time as well. The truck at the head of the platoon act as a leader, with the vehicles behind reacting and adapting to changes in its movement, requiring little no action from the drivers. In the first instance, driver will remain in a control at all times so that they can also decide to leave the platoon and drive independently. So it is not for the whole journey. Whenever they want to engage or they want to connect, they connect, so that the drivers in second and third or the connected vehicles, they don't need to do so much actions. They just sit into their vehicles and the leader will follow, and then the vehicles behind, they will follow that leader, main vehicle. What are the benefits? Clean. Truck platooning lowers fuel consumption and CO2 emission, given that trucks can drive closer together. If there is a huge difference between the trucks, there is a air resistance, and that will affect your fuel consumption and transport. When you are maintaining the lower the distance, so it will help you. The air drag friction is reduced significantly. Platooning can reduce the CO2 emission by up to 16% from the trailing vehicles and by up to 8% from the lead vehicle. Then safe. Why? Truck platooning helps to improve the safety. Braking is automatic and immediate. In driverless car, similarly. So here as well, braking is automatic, immediate. The trucks following the lead vehicle only need 1/5 of the time a human would need to detect or to react. Efficient. Platooning optimizes transport by using roads more effectively, delivering goods faster and reducing the traffic jams. The driving range, and you might ask me the question like, okay, what happens suppose one of the truck is disengaged at some roundabout or some taking the right turn or left turn. Again they will go on and they will connect with the their leader. Okay, so again very interesting videos available on YouTube. Just you search truck platooning Volvo, they have done the testing as well. You can find out that. Platooning optimizes transport by using roads more effectively, delivering goods. It allows drivers to undertake other tasks. So you can see second and third, such as administrative work or making calls to leave the platoon and drive independently. Then what are the challenges of this one? We have discussed so many applications. Tell me some challenges now. Data security is there because we are collecting huge amount of data. What else? Investment cost. Initial investment cost would be higher. What else? Technical labor. Do you means they need to improve their skills? Okay, that's why you are saying technical labor. Okay. Data storage, but we have already talking about cloud computing that stores the huge amount of data. So do you think that would be a challenge? Employability. Yeah, so some regular jobs will be affected, but because of these advanced technologies, the new jobs will be there. So you need to improve your skills based on the requirements. Analyze the data, finding out the insights. How do you connect the physical devices with your digital internet? All those things, algorithms. So here you can see some challenges. First one is the unpredictable consumer demand. So whatever technologies we are developing, IoT, all those things, it is difficult to find out the demand. Okay, shifting preferences and technology impact demands. Take the example of these driverless cars. So now, so far, it's going well. Everybody is enjoying that one because of what? Because of the cost. Cost is lower. But suddenly, suppose something happen, 1 or 2 accidents may happen or something. The customer's demand, the preference may change. They may again go back to their original traditional drivers. So that is just one example. Again, it based on the customer preferences and then technology impact. AI, ML, deep learning help predict demand and manage the bullwhip effect. Cyber security risk. IoT networks create vulnerabilities in physical and digital systems because you are collecting the huge amount of data. You are transferring from one network, one entity to another entity. So there might be the problems of cyber attacks, cyber security risk. So lack of standardized security protocols increases risk. We talked about couple of IoT architectures, but still there are no standard architectures available or standard protocols available to transfer the information or to collect the information from one end to another end. High investment cost, as you mentioned. IoT infrastructure needs sensors, network, skilled staff. So that will cost you. But over the years, suppose starting investment cost would be higher. But if you use them, over the years, maybe 5 years, 10 years, there are more benefits are there, and rate of return is also very good when you look at the long-term benefits. Costly for small businesses to implement. That's why I am talking about main, powerful member in your supply chain. They can go with the IoT. But small players, your tier 1 supplier, tier 2 supplier, tier 3 supplier, distributor, retailers, they might not have the huge budget to invest in the IoT. Then everybody needs to come. Then maybe the big player, they can help to the small players to invest in or to go with these IoT devices. Network gaps. IoT supply chain management needs continuous real-time data flow. If there is a little bit gap, like in case of your driverless car, if there is a little bit gap in finding out or in collecting the data, transferring that data, taking the action, analyzing, so it will be very problematic for the network. So that is a network gaps. IoT supply chain needs continuous real-time data. 5G and cloud enhance real-time tracking and traceability. Centralized data handling issues. Global supply chain needs decentralized system for security and transparency. Suppose your nature of the supply chain is global. You have got some suppliers located in Asia, in developing countries, and some suppliers located, distributor, retailers located in western parts of the country, and you are using the cloud-based, the network to store that data. So sometimes it is very difficult to analyze the data from the, across the different parts of the world. So that's the problem. Blockchain enables trusted data traceability and fraud prevention. Another famous technology, blockchain, it helps to make that safe and secure transaction. Okay, so tomorrow we are going to talk about this blockchain technology, how we can use this blockchain technology to make that safe and secure transaction. Again, very interesting stuff is there. We are going to talk about some of the case studies as well. IBM's blockchain, how they use the blockchain for the to trace the food supply chain. Then lack of skilled workforce. So IoT supply chain requires specialized technical expertise. Okay, so if you don't have the technical expertise, the people, those who know how to what is this IoT, how we are collecting the data, how to analyze that data, how this whole IoT system works, then it is very difficult. So that's why, suppose you are at ground level in your manufacturing, if the workers, those who are running that machine, if they don't know what is the use of these IoT devices, how you can get the timely information. Sometimes something happened to that IoT device, they will not take that IoT devices as serious as much. Okay, so everybody involved in your supply chain, it could be the workers, the third-party logistics provider or others, they need to be aware of these IoT devices, and then we need those technical expertise so that we can inform everybody the benefits of these IoT devices. Organizations must invest in professional IoT training. Okay, so there are benefits of this IoT technology. We have seen so many things, but another important thing is that the information available. So basically, all the members, they are not familiar with this IoT technology, how they can use this IoT technology, how they can get the benefits, maximum benefits of IoT technology. So governments and then maybe some the professional body, they should organize some kind of trainings so that these organizations, they get the the information about these IoT devices, how we can use them. So lack of skilled workforce means we need to improve our skills based on these the requirements, companies' requirements to implement the IoT devices. Any doubts? No? So tell me, what have you learned so far in today's session? What are the important types of IoT? Okay. What is the difference between not consumer, commercial and industrial? Commercial purpose means in commercial setting, retail, those kind of things, office, hotels, and industrial means in logistics, manufacturing. Okay. What else? What are the architectures? Okay. What those 3-layer SOE and then middleware. Okay. What else? What is the difference between cloud, edge, and fog?
So much latency in the coming to edge, the data will be processed at the source. Latency will be less. So fog will be intermediate. Other system will be there for processing.
Okay.
It's not like cloud, but it will be somewhere near the not exactly at the source.
So then does smartwatch, which technology is it using? Smartwatch? Edge computing. What about the Amazon's Alexa? Cloud computing. It is sending the commands to the clouds and then taking the actions. And what about driverless cars? Again edge computing. Okay. Then what else have you covered so far? Challenges, yeah. Role of IoT use cases, supply chain, we can say. We talked about the smart warehouses, cold chain monitoring, how we can keep the eye on the pressure, humidity inside the warehouse, inside the vehicle. Then this is the example of warehousing operations, forklift trucks. I have given the source as well here, so I am going to share the slides as well. So basically all this information I have taken basically most of the stuffs from the academic articles, reference books. So you can look at these sources here and you can find the more information about this one. Yeah. So this will be good. Suppose you are working on some project and you want to use these IoT devices, all those things. You could use these references and then you could basically make your dissertation project more attractive, more powerful. Okay. How it works, internet definitions, we talked about those stuffs. And then these some of the platforms we already discussed: Amazon Web Services, Cisco. Do you know anything else apart from this? Oracle, I don't know. I'm aware of these platforms. Google, yeah, Google Cloud, yeah. GCP is there. IBM Watson, yeah, IBM Watson. I'm aware of it. And then truck platooning. Any doubts in this one? There is very interesting video on YouTube. Volvo, they did the testing of this truck platooning, so you can find out. And now they are also basically looking into some advanced level of this truck platooning as well. So vehicle routing, it is very interesting to see the vehicle routing of this truck platooning. Okay, so how do you optimize the route using this truck platooning? So there are a couple of papers as well available on this advanced technology. And then have you tried that any logistics risk management, the smartphone supply chain case? Do you know then how to do the risk analysis using that tool? Do you know? Okay, I will basically in the bottom left corner. Let me see if I can open it here. Yes, I can show you in just. Let me see. There is where you define the parameters in the bottom left corner. There is one option available, table events. You can search the events, and then whatever the events you want to add there, suppose you want to create the fire that may occur in the future, then you create that event there. You need to define the parameters. What parameters? Like, do you know the exactly when that event will occur? If yes, you select the yes, then define when that event will occur. Then you need to define why is it occurring, what is the reason behind that occurrence. That is the one thing. Another is, when that event occurred, then how much time do you need to recover that one. So that is the second event you need to create. So once you created that event, then you run your model, and then you see the impact of that disruption on that your supply chain. And two important components in your risk management is the probability and impact. So when you define that event, it will ask you what is the probability of occurrence of that event. So if you know certainly that event is going to happen, then you can make it 100% probability. But if you have some uncertainty, like, then if you know the exact probability, the percentage, so then you can, let me input something. This is our smart supply chain. Just give me 5 minutes, guys. This is our smart supply chain. Yeah, these are the connection. 2 suppliers, one in China, one in Taiwan.